The universe is full of mysteries, some we think we understand, and others that perplex even the most brilliant minds. From the everyday enigmas of nature to the deepest questions about reality itself, science constantly discovers new layers of complexity, and for every answer we find, more questions arise. In this video, we are going to embark on a journey through the 100 greatest unsolved mysteries in science, classified from easiest to understand to the most dark and disconcerting. We will start with familiar topics, questions about space, life, and the human mind, before diving into the truly strange, where the limits of physics, existence, and consciousness itself are questioned. Some of these mysteries may be solved in our lifetime, while others may remain unanswered forever. In any case, they expand the limits of human knowledge and remind us how much we still have to discover. So get ready to explore the unknown as we start at level 1 and move up to level 100, the deepest and strangest scientific mysteries. Level 1. When we look up at the night sky, we see stars, planets, and galaxies, but surprisingly, all this visible matter only constitutes a small fraction of the universe, about 5%. Scientists believe the rest is made up of something we cannot see, something mysterious called dark matter. Dark matter does not emit light, does not absorb it, nor does it interact with electromagnetic forces, which makes it completely invisible. However, we know it must be there because of its gravitational effects upon galaxies. Without dark matter, the galaxies would disintegrate and their stars would move too fast for visible matter to hold them together. So what is it? Some theories suggest that it could be composed of unknown particles that do not interact with normal matter. Others propose more radical ideas, such as modifications to the laws of gravity. Despite decades of research and huge underground detectors looking for evidence, no one has directly observed dark matter, which remains one of physics' greatest unsolved mysteries, one that could redefine our understanding of the universe. Level 2. If dark matter is strange, dark energy is even stranger. While dark matter seems to hold galaxies together, dark energy does the opposite. It is tearing the universe apart. In the late 1990s, astronomers made a shocking discovery. The universe is not only expanding, but accelerating. This means that galaxies are moving away from each other faster and faster over time. But what is causing it? The most accepted theory is dark energy, an unknown force that makes up about 68% of the entire universe. Scientists have no idea what dark energy really is. Some think that it could be a fundamental property of space itself, a force interwoven into the universe's fabric. Others believe it could be a sign that our understanding of gravity is incomplete. Whatever it is, dark energy is shaping the cosmos' future. If its effects continue unchecked, it could end up tearing apart galaxies, stars, and even atoms in an apocalyptic scenario known as the Great Rip. For now, dark energy remains an enigma, one of the greatest mysteries in physics. Level 3. We spend about a third of our lives asleep. Yet scientists still don't fully understand why sleep is essential. Spending too much time without sleep can lead to hallucinations, memory loss, and even death. But what exactly happens when we sleep, and why do we need it in the first place? At first, sleep may seem like a major evolutionary disadvantage, as sleeping animals are vulnerable to predators, unable to find food, and to reproduce. However, all complex organisms, from humans to the smallest insects, have some type of sleep or rest cycle, suggesting that it must be fundamental for survival. One theory is that sleep helps the brain process information and store memories, almost like a biological reset. Another suggests that it plays a key role in healing and cellular repair, allowing the body to recover from daily stresses. More recent research even suggests that sleep helps eliminate toxic waste from the brain, reducing the risk of neurological diseases like Alzheimer's. However, despite all these theories, no one knows exactly why sleep evolved or what its true purpose is. It remains one of the biggest unanswered questions in biology, one that we experience every night. Level 4. Right now you're aware that you're watching this video, You can think, reflect, and experience emotions, but what exactly is consciousness, and where does it come from? At first glance, it may seem like an obvious question. Consciousness is simply being awake and aware, but when scientists try to define it, things get much more complicated. Consciousness is not just being able to respond to stimuli. It is having a subjective experience, the internal feeling of being oneself, and that is where the mystery lies. Neuroscientists have mapped different regions of the brain responsible for things like memory, emotions, and decision-making, but none of this fully explains how all these neural processes come together to create the experience of consciousness. It is one thing to understand that there are electrical signals firing in a brain, but why does that produce thoughts, sensations, and self-awareness? This is known as the hard problem of consciousness. How the physical processes of the brain give rise to the feeling of being alive and conscious. Some scientists believe that consciousness arises from the complex processing of information by the brain. The idea is that once a system like the human brain reaches a sufficient level of development, self-awareness arises naturally. Others take a more radical approach and suggest that consciousness is not just something that happens in the brain, but is a fundamental part of the universe, like space and time. This theory, known as panpsychism, proposes that consciousness exists at a basic level in all matter, even in things we consider inanimate. Then there is the question of whether human beings are the only beings that experience consciousness. We suppose that animals like dogs, dolphins, and even birds have some level of consciousness. But what about artificial intelligence? Could a machine truly become conscious of itself? If so, what would that mean for how we define intelligence in life itself? Despite years of investigation, no one has been able to fully explain what it is. It is consciousness or how it arises. It continues to be one of the biggest scientific and philosophical mysteries, one that challenges our understanding of reality itself. Scientists may one day discover the answers, but for now the question continues being, what exactly makes you you? Level 5. Have you ever been to a place you had never been before and felt that you had already lived that exact moment? This disturbing sensation is called déjà vu, which means already seen in French, but what causes it? Déjà. The déjà vu happens suddenly, lasts only a few seconds, and often is impossible to predict. Scientists have studied the phenomenon for years, but no one completely understands why it happens. Some theories suggest that it is caused by a small failure in the brain's memory system, where new experiences are processed accidentally, as if they were past memories. Others believe that it may be related to the way in which the brain processes information too fast, creating the illusion that we have already seen or done something before. There's also a theory that déjà vu could be related to dreams. Maybe we are experiencing something similar to a forgotten dream, which makes us feel strangely familiar. Some more speculative ideas even suggest that déjà vu could hint at the existence of parallel universes, moments in which we briefly submerge in an alternative version of reality. Although there is no proof of it, it continues to be a popular idea in science fiction. For now, déjà vu continues to be an inexplicable peculiarity of the human mind, something that almost everyone experiences, but that no one completely understands. Level 6. Every night. We enter a world of changing realities, strange events, and impossible experiences. Our dreams. No matter who you are, where you live, or what language you speak, you dream, but why? What purpose do these nocturnal trips serve? Scientists have been studying dreams for decades, but there is still no definitive explanation for why we dream. One of the most accepted theories is that dreams play a role in the consolidation of memory. While we sleep, the brain classifies the experiences of the day and decides what to conserve and what to discard. Some researchers believe that dreams are a byproduct of this process, since our subconscious reproduces and reorganizes the information, sometimes in ways that do not make logical sense. This could explain why we sometimes dream of events that happen during the day, but with strange and unexpected twists. Another theory suggests that dreams help us process emotions. Throughout history, people have reported having vivid dreams in moments of stress, anxiety, or important changes in life. Some researchers propose that dreaming allows us to rehearse difficult situations in a safe, imaginary space. This could be an evolutionary adaptation that helped our ancestors prepare for dangers or challenges before they happened in real life. Even today, we sometimes wake up from an intense dream with the sensation of having better understood a problem that we are facing. Then there's the idea that dreams can be completely random. According to the theory of the synthesis of activation, dreaming is only the result of the chaotic activation of the neurons while we sleep, with the brain always trying to find patterns and meaning. It takes these random signals and interweaves them in a story, often without much sense when waking up. This could explain why dreams often seem disconnected, jumping from one place to another with little connection between the events. But not all dreams are out of our control. Some people experience lucid dreams, moments in which they are aware that they are dreaming and can even influence what happens next. Lucid dreams have been studied in scientific laboratories, and researchers have confirmed that people can learn to control their oniric world to a certain point, but it is still unknown how this works and why some people can do it more easily than others. There are even more speculative ideas about dreams. Some believe that dreams could offer a glimpse into alternative realities, while others suggest that they could be a kind of hidden language of the subconscious that reveals deeper truths about our desires and fears. Although these ideas remain unproven, they highlight the importance of dreams. Despite all the investigations, no one completely understands why we dream. Are they simply the result of random brain activity, a tool to solve problems, a way to process emotions, or are they something even stranger, something that we have not yet understood? For now, the mystery of dreams remains unresolved, hidden in the deepest corners of the sleeping mind. Level 7. From the moment we are born, our bodies begin a slow and constant countdown toward aging. Our skin wrinkles, our muscles weaken, and finally our cells stop working as before. But why do we age? What is it about our biology that makes aging inevitable? At the cellular level, aging is related to damage and deterioration over time. An important factor is the shortening of telomeres, protective layers at the ends of our DNA that wear out each time a cell divides. Over time, when telomeres become too short, the cells stop replicating correctly, which causes damage to the tissues and diseases related to aging. Another theory suggests that aging is caused by an accumulation of genetic mutations and cellular waste that interfere with normal functions. Some scientists even believe that aging is a side effect of our body's efforts to combat cancer, since cells stop dividing to avoid uncontrolled growth. But here is the real mystery. Why did evolution allow aging to happen? If living organisms are destined to survive and transmit their genes, why didn't nature find a way to make us alive eternally? Some researchers believe that aging helps eliminate weaker individuals, leaving space for younger and stronger generations. Others suggest that aging was not directly designed by evolution, but is simply an inevitable consequence of biology. If we could fully understand why we age, could we stop or even reverse it? Scientists are actively investigating ways to slow down aging, and some believe that human beings could prolong it, but it is simply an inevitable consequence of biology. If we could fully understand why we age, could we stop or even reverse the process? Scientists are actively investigating ways to slow down aging, and some believe that human beings could drastically prolong their life expectancy in the future. But for now, aging remains a deeply unresolved mystery, which affects each and every one of us. Level 8. Each person on Earth has a unique set of fingerprints, a pattern of ridges and loops that remains the same throughout life. We use them to identify ourselves, but why do human beings and some animals have them? A common theory is that fingerprints help us to better grab objects, preventing them from slipping from our fingers. However, some studies suggest that this might not be true. Experiments have shown that smooth skin can sometimes create better friction than skin with ridges. Another idea is that fingerprints improve our sense of touch, allowing us to feel fine textures and detect small differences on surfaces. The ridges can help amplify vibrations and provide our brain with more information about what we are touching. On the other hand, there is an evolutionary perspective. Could fingerprints aid survival? Some scientists believe that they could have developed to help early humans and primates climb trees or handle rough surfaces more effectively. But here's the biggest mystery. Why are all fingerprints unique? Even identical twins, who share almost the same DNA, have different fingerprint patterns. This suggests that fingerprints are determined by a combination of genetic and random developmental factors. However, we still do not fully understand how or why they form in the way they do. Fingerprints are a small part of our body, but they hold a great mystery that science is still trying to solve. Level 9. Life is everywhere on Earth, from the deepest ocean trenches to the most arid deserts and the highest mountains. Our planet is teeming with living organisms, but billions of years ago, Earth was just a barren rock with no plants, no animals, not even bacteria. So how did life begin? What was the first spark that transformed simple molecules into living and evolving creatures? One of the main theories is biogenesis, which suggests that life arose from inert chemical reactions in the primitive oceans of the Earth. There were no living beings, only the first spark that transformed simple molecules into living creatures in evolution. One of the main theories is biogenesis, which suggests that life arose from non-living chemical reactions in the primitive oceans of the Earth. There were no living beings, just a mixture of simple molecules floating in the water, but the conditions on the young planet were very different from today. Volcanic activity, lightning, intense ultraviolet radiation, and other energy sources could have triggered chemical reactions that created complex organic compounds, such as amino acids and proteins, fundamental components of life. Over millions of years, these molecules could have assembled into self-replicating structures that gave rise to the first primitive cells. A closely related idea is the RNA world hypothesis. Unlike DNA, which stores genetic information but needs other molecules to function, RNA can do both: store information like DNA and catalyze chemical reactions like proteins. Some scientists believe that before complex life developed, the first forms of life were based on RNA, were able to copy themselves, and, over time, gave rise to more advanced biological systems. This idea is supported by experiments showing how RNA molecules can form spontaneously under certain conditions. However, not everyone is convinced that life originated solely from the chemical processes of the Earth. Some researchers suggest that life, or at least its fundamental components, could have come from space. This theory, known as panspermia, proposes that comets, asteroids, or interstellar dust could have transported organic molecules or even primitive microbial life to Earth from elsewhere in the universe. Meteorites have been found containing amino acids, the essential ingredients of proteins, supporting the idea that these fundamental molecules could have formed elsewhere and reached our planet. If this were true, it would mean that life on Earth could have an extraterrestrial origin, which raises an even bigger question. Did life first arise somewhere else in the cosmos? Another fascinating possibility is that life began in very different environments from what we normally imagine. Instead of forming in shallow pools or on ocean coasts, some scientists believe that the first life could have arisen near hydrothermal vents on the ocean floor. These underwater vents release heat and minerals, creating a rich environment in which complex chemical reactions could take place. Even today, extreme organisms known as extremophiles thrive in these hostile conditions, suggesting that life could have originated in a place that we previously considered too hostile to harbor it. Despite decades of research, no one has been able to recreate the exact process that gave rise to life. Scientists have conducted experiments showing that amino acids, nucleotides, and other organic molecules can form under conditions similar to those of early Earth. But taking the next step, creating a fully functional self-replicating system, is something we have not yet achieved. Without direct evidence, the true origin of life remains a mystery. If we could discover how life began, it would be one of the most important discoveries in the history of humanity. It would not only reveal our own origins, but also the possibility of life beyond Earth. If life arose naturally from simple chemical processes, it could have happened elsewhere in the universe, perhaps on Mars, Europa, or even on planets in distant star systems. But if the conditions that gave rise to life were truly exceptional, Earth could be the only inhabited world in an otherwise uninhabited cosmos. Until we find conclusive evidence, either by creating life in a laboratory or discovering it elsewhere in the universe, the question of how life began remains one of science's greatest mysteries. It is a mystery that touches the very essence of our existence and reminds us how much we still have to learn about the origins of life and our place in the universe. Level 10 gravity is one of the most familiar forces in the universe. It keeps us anchored to Earth, controls the orbits of the planets, and holds entire galaxies together. But despite being one of the 4 fundamental forces of nature, we still do not fully understand what gravity really is. Isaac Newton first described gravity as a force that attracts objects to each other. The same force that causes an apple to fall to the ground also keeps the moon orbiting Earth. But then Einstein's theory of general relativity changed everything. He proposed that gravity is not really a force, but rather a deformation of space and time. Massive objects, such as planets and stars, curve the fabric of space-time, and this curvature tells other objects how to move. But this is where things get mysterious. Although Einstein's theory perfectly explains gravity on a large scale, it does not work at the quantum level, in the microscopic world of atoms and particles. Quantum mechanics takes over, and gravity does not fit perfectly into the equations. That is why physicists have been searching for a quantum theory of gravity for so long, something that can unite the laws of the very large with the laws of the very small. And what is even stranger, we still do not know what really causes gravity. The other fundamental forces have particles that transport them, such as photons and electromagnetism. But the hypothetical particle of gravity, the graviton, has never been found. Could gravity be an emergent property of the universe? Could it be related to hidden dimensions? Or is our knowledge of physics fundamentally incomplete? Until we resolve these questions, gravity will remain one of the most persistent and perplexing mysteries of science. Level 11. The universe works thanks to a set of fundamental physical constants, fixed numbers that define how everything functions. Among them are the speed of light, the gravitational constant, the charge of an electron, and the Planck constant, among others. But here is the mystery. Why do these constants have the precise values that they do? If any of these numbers were even slightly different, the universe as we know it could not exist. If the gravitational constant were only a little stronger, the stars would burn too quickly, making life impossible. If the charge of an electron were slightly different, atoms would not form correctly, and chemistry would not work. If the cosmological constant, which influences the expansion of the universe, were only a little greater or less, the universe would collapse on itself or expand too quickly for galaxies to form. This very precise adjustment has led some scientists to wonder why these constants have their particular values. One possible explanation is the anthropic principle, the idea that the constants must be as they are because, if they were not, we would not be here to observe them. Another possibility is the multiverse theory, which suggests that our universe is only one of many, with different constants, and that we live in one in which life is possible. Others believe that there could be a deeper, unknown physical law that determines these values, but that we have not yet discovered it. Are these numbers a mere coincidence? Or do they hint at a hidden structure of reality? Until we find an answer, the precise values of the fundamental constants of the universe remain one of the greatest unsolved mysteries in physics. Level 12. The universe is expanding, but where is it going? Will it continue to expand to infinity, or is there an end point, a final destination that awaits everything we know? Scientists have been trying to answer this question for decades, but the truth is that we still do not fully understand what will happen to the cosmos in the distant future. One of the most accepted ideas is the Great Freeze, also known as the thermal death of the universe. At this time, the universe is expanding, and thanks to dark energy, that expansion is accelerating. If this continues indefinitely, then in billions, trillions, and even quadrillions of years, the galaxies will move even further away from each other. The stars will burn and die, and no new stars and black holes will form. The last structure that will remain will slowly evaporate due to Hawking radiation, leaving behind a vast icy void where nothing can happen, a dark and infinite silence that will extend into eternity. But there is another possibility, one that suggests that the universe will not expand forever. Some scientists believe that dark energy could weaken over time or even reverse its effects, allowing gravity to take control. If that happened, the universe could begin to slow its expansion and eventually begin to shrink. In what is called the Big Crunch. In this scenario, galaxies would collide, space itself would contract, and in the final moments, all matter and energy would be drawn to an infinitely dense point, similar to the singularity that started the Big Bang. Some theories suggest that, after this, a new Big Bang could occur, giving rise to an infinite cycle of universes that would expand and collapse one after another in what is known as the Great Bounce. Then there is the most dramatic scenario, the Big Rip. This theory suggests that dark energy is not only causing the expansion, but is actually accelerating at an ever-increasing rate. If this continues unchecked, there could come a time when the structure of space itself stretches too quickly, reaching a breaking point. First, the galaxies would tear apart, then the solar systems, then the planets, and finally even the atoms themselves. In the final moment, space-time would tear at a fundamental level, destroying everything in a cosmic catastrophe that would mark the absolute end of the universe. Each of these scenarios depends on forces that we do not fully understand. The future of the universe is linked to the true nature of dark energy, a force that constitutes almost 70% of everything, but which remains a complete mystery. If dark energy is constant, the universe could freeze to death. If it changes over time, we could be doomed to collapse. If it accelerates uncontrollably, everything will disintegrate. For now, we can only observe, theorize, and try to discover more clues. The final destiny of a universe remains one of the greatest unknowns of physics, one that may take millions of years or perhaps a completely new way of thinking to fully understand it. Level 13. The universe is vast, seemingly infinite, but what is beyond what we can see when we look at the night sky? We are only witnessing a small fraction of the cosmos, only the part that light has had time to reach since the beginning of the universe. This region is called the observable universe and extends to about 93,000 million light years. But is there more beyond it? What exists outside our cosmic horizon? One possibility is that the universe is infinite and continues forever in all directions. If that is the case, then space has no edge. It simply goes on, full of galaxies, stars, and planets that we will never be able to see. If the laws of physics are the same everywhere, then there could be infinite versions of our own galaxy, our solar system, and even alternative versions of ourselves existing in different parts of this infinite extension. Another idea is that the universe is finite but unlimited, which means that if we traveled far enough, we would end up returning to the starting point, as if we were walking on the surface of a sphere. In this scenario, the universe could have a curved shape, which means that space curves on itself in higher dimensions, something that we still do not have the tools to detect. But what if the universe is only a part of something even bigger? Some theories suggest that our universe could be one of many that exist within a larger multiverse. This could mean that beyond what we can observe, there are other universes, each with different physical laws, dimensions, or even completely different forms of matter and energy. Some of these universes could be similar to ours, while others could be unimaginably different, some too chaotic for life, and others with completely new types of physics. There is also the possibility that, beyond the observable universe, the physics that we know could completely break down. The constants that define our reality, such as the speed of light, the force of gravity, or the structure of atoms, may not be valid in regions of space that we can never reach. Some theories even suggest that other parallel universes could be constantly emerging, each with its own set of rules completely independent from ours. But how could we know? Since light has a speed limit, there are parts of the universe that we will never see, no matter how long we wait. The cosmic horizon, the farthest distance that light has traveled since the Big Bang, is constantly moving. And as the universe expands, some galaxies are being pushed beyond our reach forever. This means that, unless we find some advance in physics, such as traveling faster than light or the horizon, the farthest distance that light has traveled since the Big Bang is constantly moving, and, as the universe expands, some galaxies are pushed beyond our reach forever. This means that, unless we find some advance in physics, such as traveling faster than light or a way to detect signals beyond our universe, we may never be able to answer this question. For now, the mystery remains unsolved. What exists beyond the observable universe? More galaxies? Other universes? A completely different reality? We do not know, but whatever is out there, it challenges everything we think we know about existence itself. Level 14. The idea of multiple universes has fascinated scientists and philosophers alike for decades. Could our universe be just one of many? Could there be an infinite number of parallel realities, each with its own version of history, physics, and even alternative versions of ourselves? The concept of the multiverse is one of the most mind-blowing ideas in modern science. But is there any real proof of its existence? One of the strongest arguments in favor of the multiverse comes from cosmic inflation, the idea that, just after the Big Bang, the universe expanded at an incredible speed. Some theories suggest that this inflation did not occur uniformly everywhere, but that different regions of space could have inflated at different speeds, creating separate bubble universes with their own physical laws. In this scenario, our universe is just a small bubble in a vast cosmic ocean of other universes, each of which could follow different rules of physics, some familiar and others completely foreign. Then there is quantum mechanics, which adds another layer to the mystery. The many-worlds interpretation of quantum physics suggests that every time a decision is made, whether at the atomic level or in everyday life, the universe splits into multiple realities, each of which develops a different possibility. According to this idea, there could be an infinite number of versions of you, each living in a slightly different timeline in which different decisions were made. Universe. You could have chosen a different career, and in another, perhaps you would not even exist. String theory, one of the most ambitious theories in physics, also points to a multiverse. This theory proposes that reality is made up of tiny vibrating strings of energy, and that there may be additional dimensions beyond the three of space and time that we experience. Some versions of string theory suggest that these additional dimensions could give rise to completely separate universes, each with its own unique physical laws. But if other universes exist, will we ever be able to prove it? The biggest problem with the multiverse hypothesis is that it is extremely difficult, if not impossible, to test scientifically. If another universe exists, it is likely separated from ours in a way that prevents direct observation. However, some scientists think that traces of the multiverse could be detected in the cosmic microwave background, the residual radiation from the Big Bang. If another universe collided with ours in the distant past, it could have left traces in this ancient light. There are also far-fetched ideas that suggest that certain quantum experiments could one day allow us to glimpse evidence of parallel worlds. Some even propose that black holes could be access doors to other universes, although this remains purely theoretical. So, do we live in a multiverse now? We do not know. The idea remains speculative, but if true, it could mean that our reality is only one of infinite possibilities, and that what we call universe is only a small part of something much, much bigger. Until we find a way to prove or disprove the existence of other universes, the multiverse remains one of the greatest and most mind-blowing mysteries in science. Level 15. The universe is mainly composed of matter, but according to physics, it should not be. At the time of the Big Bang, equal amounts of matter and antimatter should have been created, since antimatter is matter's opposite. When both meet, they annihilate each other, and everything should have been canceled, leaving nothing. And yet, here we are, in a universe composed almost entirely of matter. This strange imbalance is called baryonic asymmetry, and scientists have no idea why it happened. One possible explanation is that, for some unknown reason, the laws of physics favored matter over antimatter in the early universe. Experiments with subatomic particles have shown small differences in the behavior of matter and antimatter, but not enough to explain why all existence was not instantly annihilated. Some theories suggest that, in the early moments of the Big Bang, asymmetries in physics allowed only the necessary matter to survive, while the rest was annihilated with antimatter. Others propose that antimatter could exist somewhere else in the universe, forming entire galaxies of antimatter hidden from us. Until we find a clear answer, the question remains, why does anything exist? The mystery of matter's survival is one of the most fundamental unsolved problems in physics, and solving it could rewrite our understanding of the universe. Level 16. The universe is full of some of the most extreme objects imaginable, but few are as mysterious as magnetars, the most powerful magnetic objects known. These ultra-dense remnants of dead stars generate magnetic fields that are 1 trillion times stronger than those of Earth, yet we still do not fully understand how they form or why they behave like this. Magnetars are a rare type of neutron star that are created when a massive star explodes as a supernova. Unlike typical neutron stars, which are already incredibly dense and contain more than one mass equivalent to that of the Sun in a sphere the size of a city, magnetars have an additional layer of strangeness, an incredibly intense magnetic field. If a magnetar were as close as the Moon, its magnetic field would be strong enough to erase the data on all credit cards on Earth. These objects occasionally release gigantic bursts of energy that produce some of the brightest flashes ever detected in space. The reason for these sudden explosions is still unknown, but they could be caused by changes in the magnetar's crust, essentially stellar earthquakes that release enormous amounts of radiation. Despite their extreme nature, only about 30 magnetars have been discovered so far, and no one knows exactly why they form in some supernovas and not others. Understanding them could not only reveal new aspects of physics about magnetism and neutron stars, but it would also help explain some of the strangest signals we detect from space, such as fast radio bursts, mysterious flashes of high energy that could be related to magnetars. For now, these objects remain one of the universe's greatest enigmas. Powerful, unpredictable, and barely understood, the Earth's magnetic field is one of the most important forces that protect life on our planet. It protects us from harmful solar radiation, helps animals to orient themselves, and even makes compasses work. But there is a mystery that scientists still do not fully understand. Why do the Earth's magnetic poles sometimes reverse? In the last 20 million years, the Earth's magnetic field has reversed approximately every 200,000 or 300,000 years, which means that the North and South poles literally exchange positions. The last complete reversal took place about 780,000 years ago, which means another one could be about to occur. But what causes these changes, and when will the next one occur? Scientists believe that the Earth's magnetic field is generated by the movement of molten iron in the outer core, creating a gigantic geodynamo. But for reasons we still do not understand, this flow sometimes becomes unstable, causing the magnetic field to weaken and eventually reverse. At this time, the Earth's magnetic field is already weakening, and some researchers believe that we may be heading towards another pole reversal in the next thousands of years. If this happens, it will not be an instantaneous change, but it could take hundreds or even thousands of years to complete. But what would it mean for us? Some scientists fear that the weakening of the magnetic field during a reversal may expose the Earth to greater solar radiation, which would affect satellites, electrical networks, and even increase cancer risk. Others believe that the effects would be minimal, since life on Earth has already survived hundreds of these reversals. Despite years of research, we still do not know exactly why these reversals occur, how to predict them, or what all their consequences might be. All we know for sure is that the Earth's magnetic poles are constantly moving and that one day they will reverse again. Level 18. Ball lightning is one of the strangest and most elusive natural phenomena ever recorded. Witnesses describe them as orbs of bright light, usually the size of grapefruit, that suddenly appear during thunderstorms. These mysterious spheres float, hang in the air, and sometimes even pass through walls before disappearing in an instant, sometimes with a loud explosion. Despite centuries of reports, scientists still do not have a definitive explanation of what ball lightning really is. Unlike normal lightning, which is well known, ball lightning seems to defy the laws of physics. Some reports describe it lasting several seconds, much longer than a normal electrical discharge. Others claim that it moves against the wind, changes direction, or even appears in doorways without a clear source. In exceptional cases, ball lightning has been reported passing through the cabins of airplanes, which increases the mystery. Many theories have been proposed, but none has been proven. Some scientists think that ball lightning is caused by microwave radiation trapped inside a sphere of plasma, while others believe that it could be metal nanoparticles in combustion released by lightning. It is even speculated that it could be a quantum effect involving strange interactions between electromagnetic fields. Because ball lightning is so rare and unpredictable, studying it in a controlled environment is almost impossible. Some researchers have tried to recreate them in laboratories with limited success. For now, it remains an unexplained mystery, one of nature's strangest and most elusive light shows. Level 19. The sun is the ultimate source of energy for life on Earth, but there is something strange about it that defies common sense. Normally, one would expect that the closer you get to a heat source, the hotter it gets. But in the case of the sun, the opposite happens. Its outermost layer, the corona, is hundreds of times hotter than its surface, and scientists still do not know why the visible surface of the sun, called photosphere, burns at about 5,500 degrees Celsius. But the corona, the bright plasma that extends millions of kilometers into space, reaches an astonishing temperature of between 1 and 2 million degrees Celsius. This should not be possible according to normal physics, since heat is supposed to flow from hot to cold, and not the other way around. One of the main theories to explain this mystery is magnetic reconnection, the idea that the constantly changing magnetic field of the sun releases bursts of energy that heat the corona. Another theory suggests that energy waves called Alvin waves could transfer heat from the sun's interior to the corona in a way that we do not yet fully understand. Despite decades of research, this coronal heating problem remains unresolved. NASA's Parker Solar Probe is currently flying closer to the sun than any other spacecraft in history, collecting data that could ultimately reveal the answer. Until then, the fact that the outer atmosphere of the sun is mysteriously hotter than its surface remains one of the biggest unknowns in astrophysics. Level 20. Around the world, thousands of people report hearing a mysterious low-frequency hum, a dull, deep noise that seems to have no identifiable source, known simply as the hum. This strange phenomenon has been heard in various places, from small towns to large cities, but scientists still do not fully understand its cause. The hum is often described as a dull and persistent noise, similar to a distant engine or a serious vibration. Interestingly, not everyone can hear it. Only between 2% and 4% of the population seems to be affected, and those who hear it often report symptoms such as headaches, dizziness, insomnia, and even nausea. The noise has been documented in places like Taos, New Mexico, Bristol, England, and Windsor, Canada, and in some cases it lasts for years. Many theories have been proposed to explain the hum. Some scientists believe that it could be caused by low-frequency sound waves from industrial activities, such as gas pipelines, high-voltage power lines, or military communication systems. Others suggest that it could be related to seismic activity or even changes in the Earth's magnetic field. Some researchers have even explored the idea that the hum is not an external sound, but a form of spontaneous acoustic emission, AO, in which the human ear produces its own low-frequency noise. More speculative theories suggest that the hum could be related to secret government projects, electromagnetic interference, or even an unknown geological phenomenon. Despite numerous investigations, there is no single explanation that fits all cases, and in many places the hum remains a mystery to those who hear it. The hum is more than just an unexplainable noise. It can be a constant and disturbing presence that disrupts sleep and daily life. Until scientists can determine its origin, the hum will remain one of the strangest and most frustrating auditory mysteries on Earth. Level 21. Time is something we all experience, but what exactly is it? We measure it with clocks, we see it pass as things age and change, and we assume that it flows in one direction, from the past to the future, but scientists still do not fully understand the true nature of time, and some theories suggest that it may not exist as we conceive it in everyday life. Time seems like a simple, continuous flow, but in physics, it is much stranger. Einstein's theory of relativity showed that time is not absolute, but can be stretched, slowed down, or accelerated depending on the speed at which you move or how close you are to a massive object. This means that time is relative, and for someone traveling at a speed close to that of light, a few hours may pass, while for another person years may pass. Even more disconcerting is that the fundamental laws of physics do not seem to require time to move in only one direction. The equations that describe motion, gravity, and quantum mechanics work just as well forward as backward. So why do we experience time moving only from the past to the future? Scientists call this the arrow of time, and one of the main explanations comes from thermodynamics, entropy. The second law of thermodynamics states that in any closed system, disorder, entropy, always increases. This unidirectional increase in entropy could be the reason why we experience time in only one direction, but no one knows why the universe began with such low entropy in the first place. Then there's the even greater mystery. Is time real, or is it just an illusion? Some theories of physics, such as loop quantum gravity, suggest that time could be an emergent property rather than a fundamental part of reality. Others propose that all moments in time exist simultaneously, which means that the past, present, and future are equally real, but our brain perceives them in a sequence. If these ideas are correct, then time as we experience it might not be a fundamental part of the universe at all, but a human perception, a byproduct of consciousness, or something even stranger that we have not yet discovered. Until we unravel its true nature, the mystery of time will remain one of the most profound questions in science. At level 22, in deep space, astronomers have detected mysterious bursts of ultra-powerful radio waves that appear randomly and last only milliseconds. They are known as fast radio bursts, and, despite years of research, no one knows exactly what causes them. Fast radio bursts were first discovered in 2007, when astronomers analyzing old telescope data found a single extremely bright flash of radio waves that lasted only a fraction of a second. Thousands more have since been detected, some coming from the depths of our galaxy, while others originate billions of light years away. The energy of just one of these bursts can be greater than what our sun emits in an entire year. At first, scientists thought that fast radio bursts might be point explosions, but then things got even stranger. Some fast radio bursts repeat from the same location over and over again, suggesting that they are not just random events, but rather some kind of unknown astronomical object that produces them under specific conditions. So what could be causing them? Some theories suggest that they come from highly magnetized neutron stars, magnetars, which could be releasing bursts of energy due to intense magnetic activity. Others think they could be related to black holes, gliding stars, or even completely unknown types of celestial objects. And then there is the more speculative idea. Could fast radio bursts be signals from an advanced alien civilization? Some researchers have considered the possibility that they may be extraterrestrial beacons or even signals from propulsion systems of intergalactic spacecraft. Although there is no firm evidence of it, the fact that the fast radio bursts are so powerful, precise, and remain unexplained keeps this theory alive. Until we discover its true nature, fast radio bursts remain one of the greatest mysteries of space. Flashes of energy that come from the depths of the cosmos arrive without warning and leave us with more questions than answers. Level 23. Imagine losing a limb and still feeling it as if it were there, experiencing sensations such as itching, pressure, or even intense pain in a part of the body that no longer exists. This strange and often distressing phenomenon is known as phantom pain, and despite decades of research, scientists still do not fully understand why it occurs. Phantom pain occurs in more than 80% of amputees and can range from mild discomfort to unbearable agony. Some people feel burning, pricking, or even movement in the limb they are missing, as if their fingers are curling or their toes are being crushed. What makes this even stranger is that it is not limited to the extremities. People who have lost breasts, eyes, or even internal organs have reported similar phantom sensations. One of the main theories is that the brain does not realize that the limb has disappeared. In the sensory map of the brain, each part of the body has a dedicated area in the somatosensory cortex, and when a limb is removed, the corresponding brain region does not simply turn off, but may begin to receive signals from nearby areas. For example, some amputees say they feel their missing hand when their face is touched, suggesting that the brain is reconfiguring itself in unexpected ways. Another possible explanation is that phantom pain arises from alterations in the nervous system when a limb is amputated. Severed nerves may continue to send signals, creating the illusion that the missing body part is still present. Some researchers believe that these nerves could misfire, sending pain signals even though there is no real limb suffering an injury. Surprisingly, treatments for phantom pain involve tricking the brain into seeing the missing limb again. One of the most effective techniques is mirror box therapy, in which the amputee places their intact limb inside a mirror box, creating the illusion that the missing limb is moving it and seeing its reflection. The brain can then recalibrate and reduce phantom pain. Despite these discoveries, phantom pain remains a profound mystery. Why do some people experience it for years, while others never feel it? Will we ever be able to completely reconfigure the brain to eliminate it? Until we unravel the complete workings of the nervous system, phantom pain will remain a disturbing reminder that the mind and body are deeply connected in ways that we still do not fully understand. Level 24. The moon has been a constant companion of the Earth for billions of years, controlling the tides, stabilizing the planet's rotation, and illuminating the night sky. But a mystery continues to baffle scientists. How was the moon formed? For decades, researchers have debated various theories about the origin of the moon. One of the oldest ideas was that the moon formed elsewhere in the solar system and was subsequently captured by Earth's gravity. However, this theory does not explain why the composition of the moon is so similar to the Earth's crust. Another idea suggested that the Earth and the moon formed together, side by side, from the same cloud of dust and gas. But if that were true, we would expect their compositions to be identical, but they are not. The most accepted theory today is called the giant impact hypothesis. According to this idea, about 45 billion years ago, a planet the size of Mars called Theia collided with the early Earth. This colossal collision would have vaporized enormous amounts of rock, sending debris into space. Over time, this material clumped together to form the moon. This theory explains why the moon is mainly composed of material similar to that of the Earth, although it has some unique differences. However, this theory still poses problems. Computer models suggest that most of the moon should be composed of material from Theia, but studies of lunar rock show that the moon is composed almost entirely of the Earth's crust, raising questions about how the impact actually occurred. Some scientists think that Theia's collision may have completely mixed its material with that of the Earth, while others believe that there may have been multiple impacts rather than just one. To solve this mystery, scientists continue to study lunar rocks from the Apollo missions, as well as data from robotic landers and orbiters. Future lunar missions could even uncover new clues hidden beneath the surface. Until then, the true story of how our closest celestial neighbor was born remains one of the greatest unknowns of planetary science. Level 25. At the quantum level, reality does not behave as we expect. Particles can exist in multiple states at once, change their behavior when they are observed, and even appear to affect each other instantaneously across great distances. But one of the greatest mysteries of quantum mechanics is something called the measurement problem. Why does a quantum particle choose a specific state when we observe it? In quantum physics, particles such as electrons and photons do not have defined positions or states until they are measured. Instead, they exist in a superposition, which means they can be in multiple places or states at the same time. This is best illustrated by the famous double-slit experiment. When electrons are fired at a barrier with two slits, they behave like waves passing through both slits at the same time and interfering with each other. But the moment we try to measure which slit the electron passes through, it suddenly behaves like a solid particle, as if it knows it is being observed. Why does this happen? Nobody knows. The collapse of the quantum wave function, the process by which the multiple possibilities of a particle are reduced to a single reality, remains unexplained. Some theories suggest that the observation itself, or the act of measuring, somehow forces quantum particles to decide on a single state. This raises profound philosophical and scientific questions about whether consciousness influences the configuration of reality. Others propose more exotic explanations, such as the many-worlds interpretation, which suggests that instead of collapsing into a single state, all possible outcomes occur in parallel universes. According to this view, measuring a particle does not force it to choose a state, but rather the universe splits into different versions of reality that manifest simultaneously. Then there is the idea that we are missing something fundamental about how reality functions. Some physicists believe that there are hidden variables, factors that we have not yet discovered, that may determine quantum behavior in ways that we do not yet understand. The measurement problem is one of the deepest mysteries of physics, and until we find an answer, we are left with a disturbing question. Does reality exist in a defined state when no one observes it? Level 26. When we look around us, space seems empty, only vast extensions of nothing between planets, stars, and galaxies. But is space really nothing, or is it something else? The true nature of space remains one of the greatest mysteries in physics. In classical physics, space was thought to be a simple passive backdrop where objects existed and events occurred, but Einstein's theory of general relativity completely changed this view. According to relativity, space is not just empty, but a flexible and dynamic fabric that can be deformed and curved by massive objects such as planets and stars. This deformation of space is what creates gravity, which means that space itself is deeply connected to the forces shaping our universe. But things get even stranger at the quantum level. Quantum mechanics suggests that even in the most perfect vacuum, space is never really empty, but is constantly filled with quantum fluctuations in which tiny particles appear and vanish in a process called vacuum energy. This strange characteristic of quantum physics is the reason some scientists believe that space itself may have an underlying structure, possibly linked to something even more fundamental, such as quantum foam at minimum scales. Even more mysterious is the idea that space might not just be something through which objects move, but a substance with its own hidden properties. Some theories suggest that space could be made up of tiny discrete blocks, much like matter is made up of atoms. If this were true, it could explain some of the biggest problems in physics, such as how to unite quantum mechanics with gravity, and, therefore, dark energy exists, the unknown force that drives the expansion of space. If space is really nothing, why is it expanding? Some scientists believe that dark energy is an intrinsic property of space itself, which means that empty space actually has its own energy, but we don't know either why or how. So what really is space? Is it a smooth fabric, an invisible energy field, or something else entirely? Until we discover the answers, the nature of space will remain one of the greatest unsolved mysteries in science. Level 27, in the depths of the ocean, thousands of meters below the surface, researchers have detected a mysterious sound that has baffled scientists for decades, known as the bloop. This ultra-low frequency noise was recorded in 1997 by underwater microphones operated by the National Oceanic and Atmospheric Administration. UU. The strange thing is that the sound was so loud that it was picked up by multiple sensors more than 3,000 m away, suggesting that it came from an unimaginably powerful source. At first, some scientists speculated that the bloop could have been caused by a huge, unknown marine creature much larger than any known so far. This idea fueled theories linking it to sea monsters, such as a real version of the Kraken, or even something completely new hidden in the unexplored ocean depths. However, later studies suggested that the bloop was probably caused by ice earthquakes, that is, the cracking and displacement of huge icebergs in the ocean. Although this explanation makes sense, it has not completely satisfied all researchers. Some argue that the unique frequency of the sound frequency and the rapid increase in tone of the sound do not coincide entirely with known noises related to ice, which increases the mystery. The deep ocean is full of other unexplained sounds, such as the upsweep, a repetitive pattern of underwater noises detected since the 1990s, and the Julius signal, another unexplained low-frequency sound captured in 1999. Could these sounds be natural phenomena, or do they point to something lurking in the ocean that we have not yet discovered? With more than 80% of the Earth's oceans still unexplored, it is possible that the bloop is just a clue to a much bigger mystery. Until we fully understand what lies in the depths, the possibility of unknown marine creatures, geological phenomena, or even scientific processes yet to be discovered remains open. Level 28. Migration is one of the most incredible behaviors in the animal kingdom. Each year, millions of birds, fish, and mammals travel thousands of kilometers, often returning to the same places with astonishing precision. But how do they know where they go? How do animals navigate across continents and oceans without maps, compasses, or GPS devices? Scientists have discovered that many migratory species use the sun, stars, and terrestrial landmarks to guide their journeys. Birds like Arctic albatrosses, which migrate more than continents and oceans without maps, compasses, or GPS. Scientists have discovered that many migratory species use the sun, stars, and terrestrial landmarks to guide their journeys. Birds like Arctic petrels, which migrate more than 44,000 kilometers each year, are guided by the position of the sun during the day and the stars at night. Sea turtles, which are born on beaches and return to the same place decades later, appear to navigate using the Earth's magnetic field, an ability called magnetoreception. But how does this work? Researchers have discovered that some animals have special magnetite crystals in their cells that could allow them to detect magnetic fields. Others may use a quantum biological process in their eyes that allows them to see the Earth's magnetic field as a faint glow or pattern. However, the exact mechanism remains unknown, and experiments have not fully explained how animals can navigate so accurately over long distances. Even more mysterious is how some species, such as salmon, are able to memorize the exact chemical signature of their birthplace and follow it back after spending years in the ocean. Monarch butterflies, which migrate thousands of kilometers to the same forests in Mexico, somehow transmit their navigation ability from generation to generation, even though no single butterfly ever completes the entire journey. Do animals possess a built-in biological GPS system? Is there an unknown sense that we have not yet discovered? Despite decades of research, animal migration remains one of nature's most puzzling mysteries, one that demonstrates how much we still have to learn about the hidden capabilities of life on Earth. In Earth Level 29, if you place two identical containers of water in the freezer, one hot and one cold, expect the cold one to freeze first, but sometimes the hot water freezes faster. This strange phenomenon is known as the Mpemba effect, and despite being observed for centuries, scientists still do not fully understand why it occurs. The effect received its name from Erasto Mpemba, a Tanzanian student who observed in the 1960s that the hot ice cream mixture froze faster than the cold mixture. Since then, experiments have confirmed that, under certain conditions, hot water can freeze faster than colder water. But why? There are several possible explanations, but none completely resolves the debate. One theory is that evaporation plays a key role. Hot water evaporates more, which reduces its mass and allows it to freeze faster. Another idea is that hot water changes its molecular structure, which affects the way it cools. Some researchers suggest that hot water develops convection currents that improve heat loss compared to cold water. More recently, some studies have proposed that differences in the behavior of hydrogen bonds in hot and cold water could be responsible. Water molecules interact in complex ways at different temperatures, and it is possible that heating changes the structure of the liquid in such a way that it accelerates freezing. However, no theory has been able to explain the Mpemba effect consistently in all situations. Some experiments demonstrate it, while others fail to reproduce the results. Even though the effect has been documented for centuries, even by Aristotle in ancient Greece, it remains a puzzling mystery for physics. Why does hot water sometimes freeze faster than cold? The answer remains unknown, demonstrating that even something as simple as freezing water can lead to one of science's strangest unsolved mysteries. Level 30. Every moment of your life, your brain stores experiences, learns new information, and retrieves memories. But how does the brain actually store and retrieve memories? Despite decades of research, scientists still do not fully understand the exact process behind one of the most fundamental aspects of human cognition. We know that memories are stored in networks of neurons, with different parts of the brain playing different functions. The hippocampus is essential for forming new memories, while the cerebral cortex helps store long-term information. When we remember something, our brain does not simply reproduce a store video, but reconstructs the memory from fragments of information scattered in different regions. But how these neuronal patterns actually encode specific details, emotions, and sensory experiences remains a mystery. One of the biggest unanswered questions is why some memories last a lifetime, while others fade quickly. Some scientists believe that stronger neural connections, reinforced by repetition or emotional importance, make memories more lasting. But why do some memories disappear completely, while others can be recalled in detail decades later? Even the strongest memories are not always accurate. Studies have shown that the brain can alter, distort, or even fabricate memories, making them unreliable. This raises questions about how memories are stored in the first place. Are they permanent records, or do they change every time we remember them? There's also the question of where exactly memories are stored. Some researchers suspect that memory is not only found in individual neurons, but could be distributed throughout the brain in a way we do not yet understand. Some even propose that quantum effects could play a role in consciousness and memory. However, this idea remains speculative until we discover the complete mechanism behind how the brain encodes, retrieves, and modifies memories. The mystery remains unsolved. How does the brain convert electrical impulses into vivid memories? How much of what we remember is real? Could we one day unlock the ability to control, edit, or even erase memories at will? For now, the secrets of memory remain hidden within the complex machinery of the human mind. Level 31 in the heart of a black hole is a place where understanding of physics completely falls apart, the singularity. According to Einstein's general relativity, when a massive star collapses under its own gravity, it forms a black hole, an object so dense that not even light can escape. But what happens at the center of a black hole remains one of the greatest mysteries of physics. A singularity is believed to be a point of infinite density and zero volume, where space and time cease to function meaningfully. The laws of physics that govern everything else in the universe, gravity, quantum mechanics, even the passage of time, no longer apply in their usual form. This means that, within a black hole, our current equations simply stop working, leaving us with more questions than answers. A major problem is that general relativity and quantum mechanics do not agree on what happens inside a singularity. Relativity predicts an infinitely dense point, but quantum physics suggests that nature does not allow infinitesimals like this to exist. Some scientists believe that singularities may not actually exist, and that some unknown force prevents matter from collapsing infinitely. One possibility is that singularities may be replaced by a state of matter yet to be discovered, sometimes called a Planck star, a hypothetical ultra-dense object in which quantum effects create a repulsive force strong enough to stop complete collapse. Others suggest that black holes could be gateways to other regions of space-time or even tunnels to other universes. Then there is the question of what happens to the information that falls into a black hole. According to quantum mechanics, information cannot be destroyed, but if there is a singularity, it would seem to erase everything that falls into it. This is known as the black hole information paradox, and resolving it could help bridge the gap between quantum mechanics and gravity. Until we develop a functional theory of quantum gravity, the true nature of a singularity remains unknown. Is it a point of infinite density, a hidden door to another universe, or something even stranger? For now, the singularity remains a place where physics itself seems to fall apart, an unsolved mystery at the limits of reality. Level 32. For decades, scientists and astronomers have sought an answer to one of the deepest questions of all. Are we alone in the universe? The size of the cosmos suggests life should be common. There are trillions of planets orbiting stars and billions of galaxies, many of which could have suitable conditions for life, and yet, despite years of searching, we have no confirmed evidence of extraterrestrial civilizations. This is known as the Fermi paradox, first proposed by physicist Enrico Fermi. The paradox asks, if intelligent life is common, why have we seen no indication of it? If alien civilizations have been around for millions or even billions of years, they should have had plenty of time to develop advanced technology, colonize other planets, or, at a minimum, send signals into space that we could detect, but so far our radio telescopes have picked up nothing but silence. There are several possible explanations for this disturbing lack of contact. One idea is that intelligent civilizations are extremely rare, and we might be among the first. Life could be common, but the development of advanced civilizations capable of space travel could be exceptionally difficult. Another possibility is that alien civilizations exist, but they are deliberately avoiding us, either because they do not want to interfere or because they consider us too primitive to communicate with. Then there is the disturbing idea known as the Great Filter, the possibility that something prevents civilizations from advancing too far. This could mean that most intelligent species self-destruct before reaching a stage where they can explore the galaxy, whether through wars, resource depletion, or technological disasters. If this is true, a disturbing question arises. Has humanity already overcome the Great Filter, or do we still have it ahead of us? Another possibility is that we are simply looking in the wrong way. Advanced civilizations could communicate in ways we do not yet understand, using neutrinos, quantum signals, or even dimensions beyond our perception, or perhaps they exist in a form so different from ours that we could not recognize them, even if we saw them. Until we find irrefutable evidence of extraterrestrial life, whether microbial, intelligent, or something beyond our imagination, the Fermi paradox remains one of the greatest mysteries of science. Are we really alone, or is the universe teeming with life that we simply have not yet found? The answer could change everything we know about our place in the cosmos. Level 33. The universe follows strict physical laws, but one presents a disturbing mystery: the second law of thermodynamics. This law states that entropy, or disorder, always increases with time in a closed system. This means that, over time, the universe should reach a state in which all energy is evenly distributed and no useful work can be done. This is known as the thermal death of the universe, a scenario in which everything, stars, planets, and even black holes, breaks down into a cold, lifeless void. But why does the universe move toward disorder in the first place? If the laws of physics allow time to move forward and backward equally, why do we always see entropy increasing rather than decreasing? This question is directly related to the arrow of time, the reason we experience time moving in one direction rather than another. While physics suggests that time should be symmetrical, our experience of time always flows from the past into the future. One possible explanation is that the universe began in a state of extremely low entropy in the Big Bang, a condition so improbable that some physicists believe it needs a deeper explanation. Why was the universe in such an orderly state to begin with? If entropy always increases, wouldn't it make more sense for the universe to have started in a highly disordered state? Instead, some scientists propose that entropy could be related to the expansion of the universe. If the universe eventually stopped expanding and began to contract, entropy could reverse, causing time to move backward, but this remains purely theoretical. Others speculate that new universes could be born from the remains of our current universe, with entropy restarting under conditions we do not yet understand. The fate of the universe depends on how entropy behaves in the long term. Will everything end up freezing in perfect equilibrium, or could new physics emerge that changes the way entropy works? Until we can answer these questions, the mystery of why the universe moves towards disorder remains one of the deepest unsolved enigmas in physics. Level 34. Most people are right-handed, but a small percentage of the population, around 10%, is left-handed. This might seem like a simple biological trait, but the truth is that scientists still do not fully understand why laterality exists or why most human beings prefer the right hand over the left. Laterality is related to the structure and function of the brain structure and function of the brain. The left side of the brain controls the right side of the body, and vice versa. Since the left hemisphere is usually dominant in language and fine motor skills, most people naturally develop dexterity with the right hand, but this does not explain why some people are left-handed or why the predominance of the right hand is so strong in all human populations. One theory suggests that laterality is genetic, but no left-handed gene has yet been identified. In fact, identical twins who share the same DNA do not always have the same dominant hand, suggesting that genetics alone do not determine laterality. Some researchers believe that environmental factors in the uterus, such as hormonal levels or fetal position, may also influence whether a person is left-handed. Even more mysterious is the question of why left-handedness persists throughout history. Left-handers were often forced to switch hands, but they still make up a constant minority in all human societies. Some studies suggest that left-handed people may have certain advantages in sports, creativity, or problem-solving, which could explain why left-handedness has never disappeared despite being less common. Interestingly, other animals also show preference for one side over the other, but humans have a much stronger right-hand dominance than most species. Why? Did evolution favor right-handedness for some unknown reason, or is laterality just a random variation without a deeper explanation? Despite decades of research, the true cause of left-handedness remains unknown. Is it purely biological, influenced by culture, or shaped by something even deeper within our brain? Until we unravel the mystery, the reason most of us prefer one hand over the other remains an unresolved enigma in human evolution. At level 35, one of the strangest and most disconcerting mysteries of physics is quantum entanglement, a phenomenon so strange that even Einstein called it spooky action at a distance. It suggests that two particles can be connected instantaneously regardless of the distance separating them, even across the entire universe. But how is that possible? Does it mean information can travel faster than light? And what does this reveal about the true nature of reality? To understand entanglement, we must first examine the strange rules of quantum mechanics. Unlike ordinary objects, which exist in defined states, quantum particles, such as electrons and photons, do not have a single fixed property until measured. Instead, they exist in a state called superposition, meaning they can be in multiple possible states at once. Now, this is where things get really strange. When two particles interact, they can become entangled, which means that their quantum states become linked to each other, regardless of the distance that separates them, whether it is a few centimeters or billions of light years. A change in one affects the other instantaneously. This means that if we measure the spin or polarization or some other property of a particle, we instantaneously know the state of its entangled twin, even if it is on the opposite side of the galaxy. This seems to defy the laws of physics, especially Einstein's theory of relativity, which states that nothing can travel faster than light. However, somehow, the information between entangled particles seems to be exchanged instantaneously, faster than light could transport a signal between them. This paradox led Einstein and other physicists to believe that quantum mechanics had to be incomplete and that there had to be some hidden variables explaining what was happening. For decades, scientists debated whether quantum entanglement was real or just a mathematical trick, but in the 20th century, a physicist named John Bell devised a way to test it, known as Bell's theorem. His work showed that if quantum mechanics was correct, entangled particles would behave in a correlated way instantaneously without hidden variables. When the experiments were carried out, the results confirmed that quantum entanglement is real and that there are no hidden variables to explain it. So, what does this mean for our understanding of reality? Some physicists believe entanglement suggests that space and time are not what they seem, that at a deep fundamental level everything in the universe could be connected. Others suggest that entangled particles are not really sending information to each other, but that they exist as a single system with no real separation, even over great distances. Then there's the even more mysterious idea that entanglement could be the key to future technology. Scientists are already exploring ways to use it for quantum computing, where entangled particles could perform calculations far beyond the capabilities of current computers. There is also the possibility of quantum teleportation, where information can be transferred instantaneously between locations. Some researchers even speculate that entanglement could one day allow instantaneous communication through space, which would revolutionize how we explore the universe, if we manage to find a way to harness it. But for now, quantum entanglement remains one of the deepest and strangest mysteries in physics. Why does this happen? What does it tell us about the nature of the universe? Could it mean that all matter, energy, and even consciousness are fundamentally connected in ways we do not yet understand? Until we find a complete explanation, entanglement challenges everything we thought we knew about reality. Level 36 nuclear fusion is the holy grail of energy production, a source of almost unlimited clean energy that could solve the global energy crisis. It is the same process that powers the sun and the stars, in which atoms fuse under extreme conditions of heat and pressure, releasing enormous amounts of energy. However, despite decades of research, we have not yet managed to make it work efficiently here on Earth. Why is fusion so difficult to achieve? Unlike nuclear fission, which splits atoms, the process used in nuclear reactors, fusion requires forcing the union of atomic nuclei, overcoming their natural repulsion. This requires temperatures millions of degrees higher than the sun's core. The challenge is not only to generate these extreme conditions, but to maintain them long enough to produce more energy than the process consumes. Scientists have built experimental fusion reactors, such as the TOX and the Stellarator, which use powerful magnetic fields to contain superheated plasma. The ITO reactor in France is currently the largest fusion project in the world, whose objective is to generate self-sustaining fusion reactions, but they are still light years away from commercial energy production. Some advances, such as laser-driven fusion, have shown promise, but none have yet reached the ultimate goal of producing more energy than they consume, a state called ignition. So what is holding us back? The biggest obstacle is plasma stability. The fusion fuel is incredibly unstable, and the extreme conditions needed to sustain the reaction make it difficult to control. Small disturbances can cause the plasma to cool or escape, which stops the process before it can generate useful energy. Some researchers believe that new approaches, such as quantum fusion, advanced superconductors, or even small-scale fusion reactors, could lead to advances in the coming decades. If we ever solve the fusion problem, it could provide virtually unlimited energy with no greenhouse gases and minimal radioactive waste. For now, nuclear fusion remains a scientific dream that could change the world if we finally manage to unravel its secrets. The question is, how much longer will we have to wait? At level 37, every second the Earth is bombarded by cosmic rays, high-energy particles that travel through space at close to the speed of light. These particles come from all directions, and while some originate in the sun, others arrive from deep space with more energy than anything we can create on Earth. But where exactly do they come from, and what accelerates them to such extreme speeds? Cosmic rays are mostly protons and atomic nuclei, but what makes them mysterious is that some have millions of times more energy than particles produced in our most powerful particle accelerators, like the Large Hadron Collider. These ultra-high-energy cosmic rays are so powerful that they should not exist, according to our current understanding of physics. Scientists believe that they must come from the most extreme objects in the universe, such as supernova explosions, active galactic nuclei, or even collisions of black holes and neutron stars. One of the biggest enigmas is how these particles can travel through the universe without losing energy. According to physics, cosmic rays should interact with background radiation and gradually reduce their speed over time. But some reach Earth with energy levels that defy expectations, suggesting they could come from sources beyond our observable universe, or that unknown physics are at play. The question also arises as to why cosmic rays appear to arrive randomly instead of coming from specific sources. If they came from a single type of event, we would expect to see patterns in their arrival. But instead they appear to be scattered, as if something, perhaps a magnetic field that extends through the galaxies, were diverting their trajectory in ways that we do not yet understand. Even more intriguing is the possibility that cosmic rays are evidence of new physics, perhaps related to dark matter, extra dimensions, or unknown particles. Some scientists have even proposed that the highest energy cosmic rays could come from decaying cosmic strings, remnants of the early universe, or even intelligent alien civilizations using unknown technologies. Despite years of study, cosmic rays remain one of the greatest unsolved mysteries in astrophysics. Where do they originate? What forces accelerate them to such unimaginable speeds? Could understanding them reveal new physics that challenges everything we think we know about the universe? Level 38. In the depths of the ocean, near hydrothermal vents where boiling water gushes from the seabed, scientists discovered one of the strangest creatures on Earth, the Yeti crab. Covered in white bristles resembling hair, this strange crustacean looks more like a sea monster than a typical crab, but stranger than its appearance is the mystery surrounding why it has this fur. Discovered in 2005, the Yeti crab, whose official name is Kiwa hiruta, lives in the extreme environment of deep-sea hydrothermal vents, where temperatures can reach 400 degrees Celsius. Unlike most crabs, which have smooth shells, the Yeti crab is covered in thick, hair-like filaments on its claws and body. Scientists initially thought these bristles could serve to filter food from the water, but later studies suggested something even stranger. The fur could harbor bacteria that the crab cultivates and then eats. If this were true, it would mean that the Yeti crab cultivates its own food in one of the most hostile environments on Earth. The bacteria could survive by feeding on the toxic minerals released by the hydrothermal vents, converting deadly chemicals into a food source for the crab. In essence, the Yeti crab could be cultivating its own bacterial garden right on its claws. This is one of the few known cases of deep-sea cultivation in nature. However, despite years of study, scientists are still not entirely sure how this process works or whether the bacteria provide all the crab's nutrition. Some researchers suspect that the crab may also feed on other small organisms near the hydrothermal vents. Another mystery is why its bristles glow under certain lighting conditions. Some theories suggest that it could be a way to attract food or scare away predators, but the real reason remains unknown. The Yeti crab is a living example of how little we know about life in the depths of the ocean. Could there be even stranger creatures living near hydrothermal vents, using biological processes completely unknown to science? Until we unravel the secrets of this furry, deep-sea enigma, the Yeti crab will remain one of the strangest and most mysterious creatures in the ocean. Level 39. We like to think that we are rational beings who make decisions based on logic and reason. But what if free will, the ability to make independent decisions, were just an illusion? Neuroscience and physics have raised serious doubts about whether human beings really have free will or if our thoughts and actions are completely determined by forces beyond our control. One of the biggest challenges to free will comes from neuroscience. In the 1980s, a famous experiment by scientist Benjamin Libet showed that the brain decides to act before we are aware of making a decision. Using electroencephalograms, Libet discovered that electrical signals from the motor cortex of the brain begin to fire milliseconds before a person reports making a conscious decision. This suggests that what we experience as a decision is actually just our brain catching up with a process that has already begun. If the brain makes decisions before we are aware of them, does that mean our choices are just automatic responses governed by brain chemistry and not by real free will? Some scientists argue that all human behavior can be explained by neuronal processes, genetics, and environmental influences, meaning that everything we do was already determined by the conditions that have shaped us. But the challenge to free will is not limited to neuroscience. Physics also raises serious doubts. If the universe follows strict physical laws, then all existing particles, including those in our brain, move according to these laws. This would mean that all our choices were predetermined from the beginning of time, like a chain reaction of cause and effect from which we cannot escape. On the other hand, quantum mechanics introduces an element of randomness. But randomness is not the same as free will. It would only mean that our actions are unpredictable, not necessarily chosen. Some philosophers and scientists argue that free will still exists in a different way, that even if our brain follows physical laws, we still own our decisions and experience them as real. Others believe that we may need a totally new understanding of consciousness and physics to explain how free will works. So, do we really have control over our thoughts and actions, or are we just biological machines following a script written by physics and biology? Until we fully understand the mind, the question of free will remains one of the deepest and most disturbing mysteries of science. Level 40. For decades, science fiction has imagined spaceships traveling faster than light and exploring distant galaxies in a matter of days. But is the warp drive, a technology that curves space itself to allow faster-than-light travel? According to our current knowledge of physics, nothing can travel faster than light, but some theories suggest that bending space-time could offer a loophole to this rule. The idea of the warp engine comes from Einstein's general relativity, which shows space-time can be curved and stretched. Instead of moving through space at speeds faster than light, a warp engine would work by compressing space in front of a ship and expanding it behind, creating a warp bubble that transports the ship along. This would mean that the ship itself does not really move faster than light, but that it is space moving. One of the most famous theoretical models for this is the Alcubierre engine, proposed by physicist Miguel Alcubierre in 1994. His equations showed that faster-than-light travel could be possible, but there is a big problem. It would require an exotic form of negative energy, something we don't yet know how to create. To make a warp bubble, we would need a material with negative mass or a way to manipulate space-time that modern physics does not allow. Some scientists think that the warp effect on a small scale could be possible. In the future, NASA has even experimented with small distortions in space using high-energy physics, but we are very far from building a real warp engine. If negative energy or exotic matter were discovered, it could change everything, but so far they remain purely theoretical. There is also the question of what would happen to anything inside a warp bubble. Would it be protected from external forces? Would it cause strange temporal effects, such as traveling to the past? Since no one has ever built a working warp engine, we still don't have the answers. For now, traveling faster than light is still the stuff of science fiction. But if advances in quantum physics or the manipulation of space-time ever reveal a way to generate negative energy, the warp engine could go from impossible to possible, allowing us to explore the universe in ways we only dream of today. Level 41. The universe seems governed by four fundamental forces: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. These forces explain everything from the behavior of galaxies to the structure of atoms. But what if there was a fifth fundamental force that we have not discovered yet? If such a force existed, it could change our entire understanding of physics, revealing hidden interactions that shape the universe in ways we have never imagined. For decades, physicists have suspected that the four known forces may not be the whole picture. The standard model of particle physics, which describes the fundamental components of the universe, is incredibly successful, but it is also incomplete. It does not explain dark matter, does not include gravity in a quantum framework, and does not explain why the universe is expanding at an accelerated rate. These gaps have led many scientists to believe that there may be an additional force yet to be discovered. One of the biggest clues that a fifth force could exist comes from anomalies in particle physics experiments. In 2016, researchers in Hungary detected unusual behavior in nuclear decay experiments, evidence of a strange new particle dubbed X17, which appears to behave in a way that does not fit with known forces. If X17 is real, it could mean that there's a new force-carrying particle, just as photons carry electromagnetism or gluons carry the strong nuclear force. This possible fifth force could be related to a dark sector of physics yet to be discovered, which could interact with dark matter, the mysterious substance that makes up approximately 27% of the universe, but remains invisible to us. Dark matter itself is one of the main reasons to suspect the existence of a fifth force. Unlike normal matter, dark matter does not interact with electromagnetic forces, which means it does not emit, absorb, or reflect light, but it does have gravitational effects that shape the way galaxies rotate and influence cosmic structures. Some scientists believe that dark matter could have its own hidden force, a dark force that only interacts with dark matter particles. If this were true, it would mean that the universe operates with an additional force that has so far remained undetectable by our instruments. Then, there is the question of gravity. Unlike the other three fundamental forces, gravity is incredibly weak compared to electromagnetism or the strong nuclear force. Some physicists have speculated that gravity may not be a force like the others, but a side effect of some deeper phenomenon. A fifth force could help explain why gravity is so weak compared to the other forces. Perhaps it is leaking into additional dimensions, or perhaps another force is acting to counteract its effects at certain scales. Another possibility is that the fifth force could be modifying gravity itself. The acceleration of the expansion of the universe, which is currently explained by dark energy, could result from a new repulsive force acting at cosmic distances. If such a force exists, it could help solve one of the biggest mysteries of cosmology: why the universe is expanding faster instead of slowing down due to gravity. If a fifth force is real, it could open the door to new physics, new technologies, and even new ways of understanding reality. Some radical ideas even suggest that such a force could play a role in consciousness, connecting the physical world with aspects of reality that we do not yet understand. Although this remains speculative, it highlights how profound the discovery of a new fundamental force would be, as it could affect everything from the nature of space-time to the deepest layers of our perception. At this time, the search for a fifth force is one of the most exciting frontiers in physics. Scientists are conducting high-energy experiments, analyzing cosmic radiation, and studying atomic interactions in search of evidence. If we discover an additional force, it could be the missing key to unifying our understanding of the universe, potentially bridging quantum mechanics and gravity. Until then, the question remains: is there a hidden force shaping the cosmos, just beyond our reach? The answer could change everything. Level 42. At first glance, the universe appears to be a vast, three-dimensional expanse filled with galaxies, stars, and planets. But what if reality is not as three-dimensional as it seems? What if everything we see, touch, and experience is actually a projection, like a cosmic hologram? This is the idea behind the holographic universe hypothesis, a theory suggesting that the fundamental nature of reality could be radically different from what we assume. The concept arose from research in quantum physics and studies on black holes, where scientists have found surprising mathematical hints that the universe could actually be a two-dimensional structure that only appears three-dimensional, like a hologram on a credit card. The idea gained relevance when physicists studying black holes made a strange discovery. They discovered that all the information about the contents of a black hole could be encoded on its surface, rather than stored in its volume. This is known as the holographic principle, the idea that a higher dimensional reality can be fully described by lower dimensional data. If this applies to black holes, some scientists believe it could apply to the entire universe. One way to think about this is to imagine a video game. When you play an open-world game, you feel like you're moving through a totally three-dimensional environment. But in reality, everything is stored as data on a flat computer chip. According to the holographic principle, the same could happen with the universe. Everything we experience could result from information encoded on a distant cosmic screen at the edge of the universe. If this theory is true, it could radically change our understanding of space, time, and even consciousness. It could help explain some of the deepest enigmas of physics, such as why gravity behaves differently than other fundamental forces. Some physicists even speculate that reality itself could emerge from this underlying holographic structure. So, is the universe really a hologram? For now, it is just a hypothesis, but one of the most mind-blowing ideas in modern physics. If it were proven true, it could redefine everything we know about the nature of existence. Level 43 in everyday life. The word vacío makes us think of nothing, nothingness, total emptiness, absolute void. But in the strange world of quantum physics, empty space is not empty at all. Even in a perfect vacuum, small energy fluctuations constantly occur at the quantum level, producing what is known as zero-point energy, the lowest energy state a system can have. This has led scientists to ask an intriguing question. Can we extract energy from a vacuum? Quantum mechanics tells us that even in the emptiest space we can imagine, virtual particles continually appear and then disappear. These tiny fluctuations create a background energy field that, in theory, could be harnessed as an unlimited energy source. This concept is sometimes called vacuum energy extraction, and if possible, could revolutionize human civilization by providing an infinite supply of energy without fuel, pollution, or resource depletion. One of the biggest proofs that vacuum energy is real comes from the Casimir effect, a phenomenon first predicted in 1948, when two uncharged metal plates are placed very close to each other in a vacuum. They experience a force that pushes them together, even though there is no external energy source. This occurs because the plates block some of the quantum fluctuations between them, creating an energy imbalance that generates a tiny force. This is experimental proof that the vacuum has real energy that, in theory, could be extracted, but turning this effect into a practical energy source is a completely different challenge. The amount of energy involved in the Casimir effect is tiny, too small to be useful. Furthermore, if vacuum energy could be freely extracted, it could lead to violations of the fundamental laws of physics, including the conservation of energy. Some theories even suggest that incorrectly harnessing vacuum energy could destabilize space itself, which could have catastrophic effects. Despite these challenges, some physicists and engineers continue to explore the possibility of extracting vacuum energy, hoping that new advances in quantum theory or exotic materials may one day unlock this hidden energy source. Whether it is possible or not, it remains one of the greatest mysteries of modern physics, one that, if resolved, could change the future of energy forever. Level 44. Laughter is one of the most universal human behaviors, but scientists still do not fully understand why it exists. Unlike basic emotions such as fear or anger, laughter has no obvious survival advantage. It is not necessary to find food, avoid danger, or reproduce. So, why did evolution favor it? One theory is that laughter developed as a form of social bonding. When people laugh together, Their brains release endorphins, which strengthen social connections and promote cooperation. This could explain why laughter is often contagious and why we tend to laugh more in groups than when alone. Another idea is that laughter evolved as a way to signal safety. Early humans may have used laughter to reassure others after realizing that a potential threat was not really dangerous, creating a sense of relief and trust within the group. Some scientists believe that laughter plays a role in cognitive processing. Humor often involves recognizing contradictions, absurdities, or unexpected patterns, and laughter could help our brains handle this type of information more efficiently. This could explain why jokes that subvert expectations tend to be the funniest and why humor is closely related to intelligence. But despite these theories, many questions remain unanswered. Why do different cultures find different things funny? Why do some people laugh uncontrollably in serious or inappropriate situations? And why does forced laughter, as in laughter yoga, seem to improve mood even when nothing is really funny? For something so natural and instinctive, laughter is surprisingly complex. Scientists continue to study it, but for now, it remains one of the many mysteries of human nature. Level 45. The speed of light is one of the most fundamental constants in physics, measured precisely at 299,792,458 meters per second in a vacuum. According to Einstein's theory of relativity, it represents the maximum speed limit in the universe. Nothing with mass can reach or exceed it. As an object approaches the speed of light, time slows down for it in relation to an external observer, and its energy needs increase infinitely. These principles have been tested and confirmed through countless experiments, making the speed of light one of the pillars of modern physics. But although we know how light behaves, we still do not know why it has this specific speed. Why is it not faster or slower? Most physical constants, such as the mass of an electron or the force of gravity, have explanations linked to deeper fundamental forces or physical properties, but the speed of light simply appears as a given value, which seems arbitrary but is deeply interwoven into the fabric of reality. If it were slightly different, the entire universe could be unrecognizable. Some physicists speculate that if the speed of light were only a little higher or lower, atoms might not form, stars might not ignite, or chemical interactions might develop at completely different rates, possibly making life as we know impossible. This suggests that the speed of light is in some way adjusted to allow a stable universe, a concept that raises profound questions about the nature of reality. But even if it is adjusted, has it always been like that, or has it changed over time? Some theories propose that in the early universe, light traveled much faster than today. This idea could help explain some mysteries of cosmology, such as the horizon problem, a paradox in which distant parts of the universe seem to have the same temperature despite being too far away to have exchanged information at the speed of light. If light moved faster in the past, these regions could have been in contact, which would have allowed them to reach thermal equilibrium. However, this idea remains speculative, as there is no conclusive evidence that the speed of light ever varied. Another profound mystery is why the speed of light is the same for all observers, regardless of their movement, unlike sound or water waves, which depend on the medium through which they travel. Light behaves differently. It moves at the same speed regardless of the speed at which the observer moves relative to it. This concept, first demonstrated by the Michelson-Morley experiment in 1887, shattered classical physics and led directly to Einstein's special relativity theory. But why the universe is structured this way remains an unanswered question. Some physicists believe that the explanation lies in the very geometry of space-time, while others think it could point to unknown vacuum properties. There is also the question of whether the speed of light is really the fastest possible speed in the universe. Some models of theoretical physics suggest that there could be hypothetical particles called tachyons that always travel faster than light. If they existed, they would violate causality, allowing paradoxes and time travel. So far, no tachyon has been detected, but the possibility remains an open research area. Meanwhile, quantum mechanics adds even more strangeness. Quantum entanglement allows two particles to influence each other instantaneously, no matter how far apart they are, appearing to violate the cosmic speed limit. Although this does not allow faster-than-light communication, it suggests that information in the quantum world behaves in ways we do not yet understand. The speed of light governs everything in the physical universe, from the way galaxies evolve to the limitations of human technology. It determines the structure of reality as we know it, but its precise nature remains difficult to fully understand. Is it really a fixed constant, or is it a consequence of deeper, hidden physical laws? Could it someday be manipulated, opening the door to completely new technologies? For now, why light moves at this exact speed remains one of science's greatest mysteries. Level 46. In a vast void of space, spacecraft follow the precise laws of physics, except when they don't. The Pioneer anomaly is one of the strangest unsolved mysteries of space exploration. When NASA's Pioneer 10 and Pioneer 11 spacecraft were launched in the 1970s to explore the outer solar system and beyond, they followed their predicted trajectories for decades. But as they moved away from the sun, scientists noticed something strange. Both probes were slowing down slightly more than expected, as if an unknown force was pulling them. The effect was small, just a slight acceleration toward the sun, but it was measurable and completely inexplicable by any known force. Scientists spent years trying to determine whether this slowdown was caused by gravitational effects, solar radiation pressure, gas leaks, or even an error in their tracking systems. But none of these explanations fully accounted for the anomaly. One of the first suspects was thermal radiation. Spacecraft generated heat from their energy sources, and if this heat was emitted asymmetrically, it could theoretically create a small thrust that altered their movement. Some studies suggested that this effect could explain the anomaly, but other scientists argue that the thermal explanation does not fully fit the data. Another idea is that the Pioneer anomaly could indicate a flaw in our understanding of gravity. If gravity behaves slightly differently at great distances, or if there are unknown forces at play, this could explain why the probes move unexpectedly. Some researchers have even proposed that this could be evidence of a new fundamental force or even modifications to Einstein's theory of gravity. More speculative theories suggest that the Pioneer anomaly could be caused by dark matter, the mysterious invisible substance that makes up most of the universe's mass. If the spacecraft were moving through a cloud of dark matter, subtle interactions could be altering their movement in ways we do not yet understand. There's also the possibility that the anomaly is related to quantum effects in empty space. Some hypotheses propose that space itself is not a true vacuum, but contains small energy fluctuations that could affect spacecraft in unexpected ways. If this idea is correct, it could revolutionize our understanding of the fundamental nature of space. For years, the Pioneer anomaly remained one of the enigmas of astrophysics, raising profound questions about physics, gravity, and the limits of our knowledge. Although some scientists believe that thermal radiation explains most of the effect, the debate is not entirely settled. If it turns out to be something more than simple heat, it could lead to a new understanding of the forces that govern the universe. Level 47 synesthesia is one of the strangest and least understood phenomena of a human mind. It is a neurological condition in which the senses are mixed. People with synesthesia can see colors when they listen to music, taste words, or associate numbers with personalities. Although it may seem like something out of science fiction, synesthesia is a real and documented condition that affects a small percentage of the population. However, despite its existence being well established, scientists still do not fully understand why it occurs or what causes it. One of the main theories suggests that synesthesia occurs due to increased connectivity between different sensory regions in the brain. In most people, sensory processing areas such as vision, hearing, and taste are relatively separate, but in people with synesthesia, these areas appear to be more interconnected, leading to an involuntary mixture of experiences. This could be due to genetic factors, as synesthesia is often hereditary, suggesting that it could be a trait integrated into the brain structure. However, this does not explain why some people develop synesthesia later in life, or why certain forms seem to appear randomly. Another mystery is whether everyone is born with synesthesia and lose it over time. Some researchers believe that babies experience the world in a highly interconnected way, in which all the senses are mixed, but as the brain develops, these connections become more specialized and separate. If this is true, then synesthetes could simply retain some early neural pathways into adulthood, while others lose them. However, this remains an open question, since studying sensory perception in newborns is extremely difficult. The variety of synesthetic experiences also raises further questions. Some forms are constant and last a lifetime. For example, someone with grapheme color synesthesia will always see the letter A as red and the number 7 as green, and these associations never change. But in other cases, synesthetic experiences can change or fade over time, leading scientists to wonder if the brain is capable of reconfiguring itself to enhance or suppress these connections. There are even reports of people developing synesthesia after brain injuries or consuming psychedelic drugs, suggesting that the potential for sensory mixing may exist in all people, but it is normally latent. The question also arises whether synesthesia provides any cognitive advantage. Some studies suggest that synesthetic people tend to have better memory, especially for things involving their unique associations. For example, someone who sees colors when reading words might remember information more easily because their brain encodes it in multiple ways. Some synesthetic people also report greater creativity, and a disproportionate number of them are artists, musicians, or writers. This has led to speculation that synesthesia could have played a role in human evolution, providing some individuals a richer sensory experience that helped them in artistic expression, communication, or even survival. However, despite these ideas, great mysteries still exist. Why do different synesthetes experience different types of sensory mixing? Why do some people report mild and fleeting synesthetic experiences, while others have intense versions throughout their lives? Could it be that all human beings experience weak forms of synesthesia without realizing it? For example, associating high-pitched sounds with sharp objects or darker colors with lower musical notes. Level 48, in the depths of the ocean, where sunlight never reaches and the pressure is crushing, life has found a way to thrive. But among the strangest creatures discovered in these extreme depths is the zombie worm, or Ostax, a strange species that survives by feeding on the bones of dead whales. What makes these worms truly mysterious is how they digest bones without a mouth or stomach. Instead of eating conventionally, zombie worms secrete acids that break down bone, allowing them to extract nutrients with the help of symbiotic bacteria living inside their bodies. But although this process is partially understood, scientists still do not know how these worms locate whale carcasses in the vast and monotonous depths of the sea, since dead whales that sink to the bottom of the ocean are infrequent and are scattered thousands of kilometers away. It is not clear how Ostax finds them so effectively, which adds to the mystery. The discovery of the OSA fossil suggests that these worms have existed for millions of years, which means they probably survived periods in which whale populations were much smaller than today. This raises the question of what they fed on before whales evolved. Some researchers suspect that they may have originally fed on the bones of giant marine reptiles, such as plesiosaurs during the age of dinosaurs, and, over time, moved on to new food sources. But if that is the case, why have we not found clear fossil evidence of Ostax in prehistoric bones? The question also arises as to how these worms reproduce. Male Ostax are microscopic and live inside the body of females in a strange parasitic relationship, but it is not clear how their reproductive cycle is triggered or whether they depend on external environmental signals. Despite living in some of the most extreme and least explored areas of the planet, zombie worms have thrived for millions of years. But how they locate food, how they survived before whales, and the details of their reproduction remain unanswered questions, making them one of the many strange and inexplicable creatures of the depths. Level 49 of intelligence is one of the most complex and debated concepts in science. We recognize it when we see it, but defining it precisely remains a challenge. Is intelligence simply the ability to solve problems? Is it the ability to learn, remember, and reason? Or does it involve creativity, social awareness, and even consciousness? Despite decades of research in psychology, neuroscience, and artificial intelligence, there is still no single, consensual definition of what intelligence really is. One of the main difficulties in defining intelligence is that it seems to exist in many different forms. Human intelligence includes logical reasoning, emotional understanding, abstract thinking, and the ability to plan for the future. Animal intelligence, on the other hand, varies greatly. Crows use tools, dolphins recognize themselves in mirrors, and octopuses solve puzzles. Even within human beings, intelligence is difficult to quantify. Traditional IQ tests measure logical and mathematical ability, but do not necessarily capture creativity, social intelligence, or adaptability, traits that are just as important for success in the real world. Then there is the question of artificial intelligence. Computers can now outperform human beings in tasks such as playing chess, recognizing faces, and even writing texts. But does that mean they are intelligent? Many argue that AI is still fundamentally different from human intelligence because it lacks understanding, self-awareness, and the ability to set independent goals. Others believe that intelligence is simply a matter of processing information efficiently, which means that AI could eventually surpass human intelligence in all aspects. But if an AI can simulate intelligence so well that it becomes indistinguishable from human thought, does it matter if it is truly conscious or not? Some researchers believe that intelligence is not a unique trait, but a set of different skills arising in response to challenges. Howard Gardner's theory of multiple intelligences suggests that intelligence comes in many forms, including linguistic, musical, spatial, kinesthetic, interpersonal, and intrapersonal intelligence. If this is true, then measuring intelligence through a single number, such as IQ, may be an oversimplification. There's also a deeper mystery. Where does intelligence really come from? How does a set of neurons in the brain give rise to conscious thoughts? Scientists have mapped many regions of the brain involved in memory, reasoning, and problem-solving, but no one has found the precise mechanism that generates intelligence itself. Some theories suggest that intelligence arises from the complexity of neural networks, while others propose it is linked to quantum processes at the microscopic level. As we continue to study the brain, artificial intelligence, and the intelligence of other species, we may better understand what intelligence really is. But for now, intelligence remains one of the greatest unsolved mysteries, one that shapes our world, but that we still find difficult to define. The Level 50 Tabby star is one of the strangest stars ever observed, located about 1470 light-years away in the constellation of Cygnus. It first caught attention in 2015 when astronomer Tabitha Bayagian and her team noticed something unusual. Its brightness fluctuated in a way that defied explanation. Most stars dim periodically due to the passage of planets in front of them, but the darkening of the Tabby star was irregular, extreme, and unpredictable. Sometimes, the brightness of the star was reduced by up to 22%, much more than a typical planet could cause, and these drops did not follow any obvious pattern. Scientists rushed to find an explanation, but all natural causes seemed insufficient. One of the first possibilities that was considered was a swarm of comets, but for that to be true, there would have to be an impossibly large number of them in orbit around the star. Another theory suggested clouds of dust or fragments of a planetary collision, but infrared observations showed no excess of heat, something that would be expected from an event of that type. Then the most exciting and controversial idea arose: an alien megastructure. Some researchers speculated that the unusual darkening could be caused by a Dyson sphere, a hypothetical structure built by an advanced civilization to capture its star's energy. Although there is no solid evidence to support this theory, the strange behavior of the Tabby star fueled speculation about the possibility of intelligent extraterrestrial life. In response, astronomers used radio telescopes to look for artificial signals coming from the star, but so far none have been detected. The mystery deepened when later studies showed that the Tabby star not only darkens in short bursts, but also seems to gradually fade over time. More than a century of observational records suggest that the star has been losing brightness at an unusual rate, something not seen in normal stellar evolution. This long-term darkening remains unexplained, adding another layer of mystery to an already strange celestial object. More recent observations suggest that the darkening could be caused by irregular dust clouds that block different wavelengths of light with varying intensities. This is the most accepted explanation today, but it still does not fully explain the extreme and unpredictable drops in the star's brightness. Some astronomers believe that multiple factors could be influencing it, such as an unusually complex planetary system, unknown cosmic phenomena, or even processes that we have not yet discovered. Despite years of study, no theory fully explains what is happening with the Tabby star, which remains one of the most puzzling and intriguing objects in the galaxy, challenging our understanding of stellar behavior. Whether the answer lies in an unknown astronomical phenomenon or something even more extraordinary, the mystery of the Tabby star continues to captivate scientists and the general public. Level 51, the quantum tunnel, is one of the strangest and most counterintuitive phenomena in physics, which challenges our classical understanding of movement and energy barriers in the macroscopic world. If an object encounters a wall or an obstacle and does not have enough energy to pass through it, it stops or bounces. Imagine trying to roll a ball up a steep hill. Unless it has enough speed, it will not reach the other side. But in the strange world of quantum mechanics, particles do not behave like small billiard balls, but also have wave properties, and these waves allow them to do something that seems impossible: cross barriers that, according to classical physics, should be impenetrable. At the heart of this phenomenon is the wave function, a mathematical description of the possible locations and behaviors of a particle. In quantum mechanics, particles such as electrons, protons, and even atoms do not exist as fixed points in space, but are described by a probability wave, which means that their exact position is not determined until measured. When this wave encounters a barrier, instead of stopping completely, it extends into the barrier and sometimes passes through. If the barrier is thin enough, part of the wave can emerge on the other side, which means that there is a probability that the particle will appear beyond the barrier, even though it never had enough energy to overcome it in the classical sense. This effect is known as quantum tunneling. Quantum tunneling is not just a theoretical peculiarity, but plays a crucial role in many real-world phenomena. One of its most important applications is nuclear fusion, the process that powers the sun and stars. In classical physics, the positively charged nuclei of atoms should repel each other due to electrostatic forces, preventing them from getting close enough to fuse. However, due to the quantum tunneling effect, these nuclei can sometimes pass through this energy barrier and fuse, releasing enormous amounts of energy in the process. Without the quantum tunneling effect, the sun would not shine, and life as we know it would not exist. Beyond astrophysics, the quantum tunneling effect is also essential for modern technology. Tunneling microscopes, for example, use this effect to image individual atoms on surfaces, allowing scientists to study materials with an unprecedented level of detail. Electronics. Modern transistors and computer chips rely on the tunneling effect to switch states, allowing for faster and more efficient processing. The flash memory used in USB drives and solid-state hard drives also takes advantage of the quantum tunneling effect to store data. Despite its practical applications, the quantum tunneling effect raises profound philosophical and scientific questions. How does a particle decide when across the barrier? Does it momentarily disappear inside the barrier or take an unknown path through higher dimensions? Some interpretations of quantum mechanics suggest that the tunneling effect occurs because particles explore multiple possible paths that exist simultaneously in a superposition of states until they emerge on the other side. Others propose that quantum mechanics allows brief violations of the classical conservation of energy, allowing the particle to momentarily borrow energy to cross the barrier before returning to a lower energy state. Even stranger, The quantum tunneling effect seems to occur instantaneously. Experiments suggest that a particle can jump through a barrier without actually traversing it at a measurable speed. This challenges our conventional notions of space, time, and causality, suggesting that our understanding of reality itself may be incomplete. There are still many unanswered questions about quantum tunneling, and it remains an active area of research in quantum physics. Could it be harnessed for new energy sources or for faster-than-light communication? Could it help us understand the true nature of time and space as we continue to explore the limits of quantum mechanics? The tunneling effect remains one of the most fascinating and mysterious aspects of the universe, blurring the line between the possible and impossible. Level 52 Venus, often called Earth's twin for its similar size and composition, has long been dismissed as a candidate to harbor life due to the extreme conditions on its surface, with temperatures high enough to melt lead and an atmosphere dominated by dense clouds of sulfuric acid. However, scientists have focused their attention on a different possibility, the planet's upper atmosphere. At about 50 kilometers above the surface of Venus, the temperature and pressure are much more similar to those of Earth, creating a region where, hypothetically, life could exist. In 2020, researchers detected traces of phosphine gas in the clouds of Venus, a chemical substance that is often associated with biological activity on Earth. This discovery aroused enthusiasm and debate, since, although phosphine can be produced by non-biological means, such as volcanic activity or lightning, there are no known chemical processes on Venus that can explain the levels observed. If there is life in Venus' atmosphere, it would probably take the form of microbes capable of surviving in highly acidic conditions. Some extremophiles on Earth, such as acid-resistant bacteria, offer a potential model of how life could persist in such an environment. The idea is not entirely new. Carl Sagan proposed the possibility of life in Venus clouds as early as 1967. Despite the intrigue, skepticism persists. Subsequent studies have questioned the accuracy of the phosphine detection, and alternative explanations have been proposed. More data is needed to determine if the signal was real, and, if so, whether it has a biological origin. Upcoming missions aim to explore Venus in more detail, which could provide answers to one of the most intriguing scientific mysteries. Could there be life in the clouds of Venus? Level 53. Some organisms exhibit strange survival mechanisms that challenge our understanding of life and death. Tardigrades, microscopic creatures known as water bears, can survive in the vacuum of space and withstand radiation thousands of times stronger than what would kill a human and enter a state called cryptobiosis, in which they basically stop all biological processes and then revive as if nothing had happened. Wood frogs can freeze completely in winter with their hearts completely stopped and then thaw and resume their lives in spring. Certain bacteria have been revived from permafrost after remaining dormant for thousands or even millions of years. Lobsters do not appear to age in the same way as other animals, as they continuously grow and molt, raising the question of whether they could be biologically immortal under the right conditions. But how do these creatures stop biological deterioration, repair damaged cells, and resume life after extreme conditions? What mechanisms allow some to cheat death, while other organisms, especially humans, inevitably succumb to aging, disease, and cellular degradation? Scientists are only beginning to understand the molecular and genetic processes that underlie these capabilities. Could unraveling these secrets lead to advances in human longevity, suspended animation, or even the reversal of death itself? If some life forms can survive the extreme conditions of space, the pressures of the deep sea, or total metabolic collapse, what does that mean for the limits of biology? Are there organisms on Earth that have already achieved something akin to immortality? And could we one day apply their survival strategies to humans? The answers to these questions could redefine what it means to be alive. Level 54. Neutron stars are some of the most extreme objects in the universe, formed when massive stars explode in supernovas and leave behind ultra-dense remnants. These remnants are so dense that a single piece of neutron star material the size of a sugar cube would weigh billions of tons on Earth. They rotate rapidly, sometimes hundreds of times per second, and emit beams of electromagnetic radiation that make them detectable as pulsars. However, neutron stars present a strange and unexpected phenomenon known as a glitch. These glitches are sudden and unpredictable jumps in their rotational speed. Normally, neutron stars lose energy over time, which causes them to gradually slow down, but during a glitch this deceleration is abruptly interrupted and the star's rotation speed suddenly increases. After the glitch, the neutron star may return to its previous slowing rate, but the cause of the phenomenon remains unknown. One of the main theories to explain neutron star glitches has to do with their exotic internal structure. A neutron star is not just a solid sphere, but has layers, including a crust and an inner core. The outer crust is rigid, while the interior contains a superfluid, a strange quantum state of matter in which particles move without friction. According to this model, as the neutron star slows down over time, the superfluid inside does not slow down at the same rate as the crust due to the lack of friction, which creates a difference in the rotational speed between the superfluid and the rest of the star. Over time, the difference becomes too great, and the superfluid suddenly transfers some of its angular momentum to the crust, causing the entire star to rotate in a glitch. Another theory suggests that the neutron star's crust could be responsible. Over time, tension builds up in the crust due to the star's intense gravitational and magnetic fields. When the tension becomes too great, the crust can suddenly break, releasing energy and altering the star's rotation. This idea is similar to how earthquakes occur on Earth, but on extreme cosmic scale. Despite these theories, neutron star glitches remain a mystery. Not all neutron stars experience glitches, and the timing of when they occur is unpredictable. Some stars experience frequent glitches, while others go decades without one occurring. Understanding these phenomena could help scientists learn more about the exotic physics that occurs inside neutron stars, where matter exists in states not found anywhere else in the universe. By studying glitches, astrophysicists hope to gain a deeper insight into quantum mechanics, nuclear physics, and the behavior of matter under extreme conditions. These strange phenomena challenge our understanding of how the fundamental forces of nature interact, making them one of the great unsolved mysteries of modern astrophysics. Level 55. Some people claim to remember events that never happened, a strange and disturbing phenomenon often referred to as the Mandela effect. This name comes from the widespread but false recollection that Nelson Mandela died in prison in the 1980s, despite being released and living until 2013. People vividly remember the coverage of the news, the speeches, and other details that never existed. But how can so many people misremember the same thing? An explanation comes from false memories, a well-documented psychological effect. Our brains do not store memories like a video recorder, but reconstruct events each time we remember them. Over time, details change, merge, or become distorted based on new information. This occurs at an individual level, but social reinforcement can amplify it when people discuss and validate each other's false memories, reinforcing them and making the incorrect details seem more real. Another theory has to do with confabulation, in which the brain fills in the missing information with invented but credible details. This is common in people with brain injuries, but it also occurs in everyday life. Small errors in memory can spread and become real for those who believe them. Some researchers suggest that misinformation and changes in collective memory play an important role when an incorrect fact appears in books, television programs, or on the internet, as it can take root in public knowledge. For example, many people mistakenly remember the famous phrase of Snow White as little mirror," when in reality it is magic mirror. Popular culture and repetition reinforce the false version. One of the strangest theories is that these false memories result from parallel universes or alternative timelines. Some believe that changes in reality cause certain groups, to remember a past that no longer exists. Although there is no scientific evidence to prove it, the idea is popular among those who experience multiple false memories that seem inexplicably real. Neuroscience offers clues as well. Studies show that the brain is very susceptible to suggestion and that memories can be easily manipulated. Experiments have shown that simply hearing a different version of an event can cause people to remember things that never happened. The hippocampus, which is responsible for storing memories, sometimes confuses imagination with reality. Ultimately, the phenomenon of remembering events that never happened reveals the fragility of human memory. While some explanations are based on psychology and neuroscience, the experience itself remains deeply disturbing for those who are convinced that their memories are accurate, whether a trick of the mind or something more mysterious. It remains one of science's strangest enigmas. Level 56. Why do different animals and even human beings experience time at different speeds? Some creatures, such as birds, insects, and small mammals, seem to perceive the world in slow motion, reacting to stimuli much faster than human beings. A housefly, for example, can dodge a clap with almost instantaneous precision, as if time ran more slowly for it. Meanwhile, larger animals, such as elephants, seem to live in a much slower perception of reality, moving slowly and reacting at a different rate. Even among human beings, the perception of time is inconsistent. Time seems to stretch during moments of extreme fear or stress, such as in car accidents, but accelerates as we age, making childhood summers seem endless and adult years blur. Certain drugs, meditation practices, and neurological conditions can also manipulate the perception of time, leading to experiences in which minutes seem like hours or entire days disappear in what seems like an instant. Scientists have proposed multiple explanations for this strange phenomenon, but none offers a complete answer. One theory suggests that the metabolic rate of an organism plays a crucial role. Animals with rapid metabolisms, such as small birds and rodents, process information more quickly, making the outside world seem slower in comparison. This could explain why a fly dodging a fly swatter seems to react in an instant. It may experience reality with a more precise resolution than we do. Conversely, animals with slower metabolisms can experience time in longer intervals, resulting in slower reactions. Another idea is that the perception of time relates to the speed of neural processing of an organism. The faster the brain can process visual and sensory information, the more frames per second it effectively perceives, allowing it to capture more details in the same amount of objective time. If this is true, different species could be living in very different subjective versions of reality, in which a second for one creature may seem like an eternity for another. The mystery deepens when we consider the perception of time in human beings. Why does time seem to speed up as we age? One possibility is that our brains measure time in relation to the total duration of our lived experience. For a 5-year-old child, a year is a huge 20% of their life, while for a 50-year-old person, it is only 2%. This means that each new year feels shorter as we age. However, there are deeper and less understood mechanisms at play. Experimental studies suggest that the more novel experiences we have, the slower time seems to pass in retrospect. This could explain why childhood, full of new experiences, seems longer in retrospect, while adulthood, often marked by routine, seems to fly by. Similarly, when the brain enters survival mode, such as during a traumatic or life-threatening event, it seems to process sensory information with extreme efficiency, creating the illusion of slow motion. This effect has been documented in soldiers, extreme athletes, and accident survivors who remember seeing every detail in an apparently prolonged time. This raises an even more puzzling question. If the perception of time is flexible, could we someday learn to control it? Some researchers are exploring whether meditation, brain stimulation, or pharmacological interventions could alter the brain's perception of time, allowing us to slow down or accelerate our personal experience of reality. If future technologies could hack the perception of time, human beings could someday experience seconds as if they were hours, gaining more time to react in crucial moments or even prolong the subjective experience of life. But, for now, the exact mechanism that explains why different beings experience time so differently remains a mystery that mixes neuroscience, evolution, and the fundamental nature of how we interact with reality itself. Level 57. Scientists have long debated the origin of water on Earth, and despite extensive research, the answer remains one of the great mysteries of planetary science. The most common hypothesis is that Earth's water comes from asteroids or comets that collided with the planet billions of years ago. These celestial bodies contain ice and, when impacting the young Earth, could have contributed large amounts of water to its surface. However, this theory poses some problems. The isotopic composition of the water of the Earth does not coincide perfectly with that of the comets, which suggests that these were not the main source. Another theory suggests that water was present in the Earth's formation from the beginning. Some scientists propose that the water was trapped in the minerals of the protoplanetary disk that formed Earth, and that it was released gradually through volcanic activity and degassing. This would mean that the water always formed part of Earth's chemistry, instead of being something that arrived later. Recent studies have even suggested that water could have been preserved in the depths of the terrestrial mantle since the planet's formation, which adds more mystery. Some investigations point to a combination of external and internal sources. It is possible that asteroids and comets contributed water, but a significant part could also come from the planet itself. The question remains, how did Earth end up with so much water when other rocky planets of the solar system, like Mars and Venus, have so little? Understanding where Earth's water comes from is not only important for our own planet, but it also affects the search for habitable worlds in other parts of the universe. If the contribution of water is common through asteroid impacts, then many exoplanets could have oceans like Earth. However, if unique geological conditions are required, then truly Earth-like planets could be rare. Despite decades of research, the precise origins of Earth's water remain uncertain. Scientists continue analyzing meteorites, studying minerals from the deep sea, and carrying out simulations of planetary formation to discover the answer. Until then, the question of where Earth's water really comes from remains one of the most intriguing and unresolved mysteries in science. Level 58. Scientists have classified many states of matter beyond the known solid, liquid, and gaseous, such as plasma, Bose-Einstein condensates, and even exotic forms such as gluon plasma. But what if completely new and natural states of matter existed somewhere in the universe that are totally unknown to us? Could materials or physical structures form in extreme conditions that challenge our current understanding of atomic and subatomic behavior? One possibility is that dark matter itself has states that we have never found, although we still do not know exactly what it is composed of. Some theories suggest that it could group together to form stable, exotic structures that interact in ways that we cannot currently measure. If dark matter forms complex configurations, it could mean that entire planets or even star-like objects exist in an invisible and undetectable form. Could there be condensates of dark matter floating through space and behaving like a completely new form of physics? Another intriguing idea is that space-time itself could have properties of matter under certain conditions. Some physicists propose that space-time could act as a kind of superfluid at the quantum level, which means that it could flow and behave similarly to a liquid under the right circumstances. If this were true, it could change our understanding of black holes, cosmic expansion, and even gravity itself. What if certain regions of the universe contained hidden layers of space-time that behave in a way that we have not yet begun to explore within neutron stars, which are some of the densest objects in the universe? Matter is compressed so intensely that the atoms themselves collapse, forming a sea of neutrons. But some scientists believe that even stranger things could happen at these extreme densities. There could be completely new superdense crystalline structures made of subatomic particles, which some have called hypercrystals. These structures could be stronger than anything found on Earth and could contain secrets about the fundamental components of reality. Then there's the idea of prawn matter. Current physics suggests that the quarks that make up protons and neutrons are the smallest known fundamental particles, but some theories propose that the quarks themselves could be composed of even smaller building blocks called prons. If prons exist, then there could be an entire hidden layer of physics beneath what we currently understand. Could there be complete forms of matter composed of these hypothetical particles waiting to be discovered? If we ever manage to detect or create one of these unknown states of matter, it could completely reshape science and technology. Imagine if we found materials that could withstand extreme forces, conduct energy in ways never imagined possible, or even reveal new laws of physics. The universe could be full of matter that exists outside of everything we have found so far, hidden in places that our current tools simply cannot reach. For now, these ideas remain purely theoretical, but the more we explore the cosmos and expand the limits of physics, the more we may discover that nature has many surprises in store for us, some of which could completely redefine what we thought matter was. Level 59. Black holes are often considered cosmic vacuum cleaners that devour everything that crosses their event horizon. But what if instead of being just destructive forces, they could be harnessed as a source of energy? Some physicists believe that black holes could be one of the most powerful energy generators in the universe. A theoretical method for extracting energy from a black hole is the Penrose process. This idea, proposed by physicist Roger Penrose, suggests that energy can be extracted from the ergosphere of a rotating black hole, the region just outside the event horizon where space itself is dragged by the immense gravitational force. In theory, if an object is sent to this region in the right way, it could be divided into two parts, one falling into the black hole and the other escaping with more energy than the original object had. This would allow, in essence, us to steal energy from the rotation of the black hole. Another potential method is the Blanford's-Najac process, which involves the interaction of magnetic fields with a rotating black hole. If a black hole is surrounded by an accretion disk, a rotating mass of matter that is attracted towards the event horizon, strong magnetic fields can form. These magnetic fields, together with the rotation of the black hole, could extract energy and convert it into powerful jets of radiation and particles. Some astrophysicists believe that these jets, which fire at speeds close to that of light, could be harnessed for energy. Then there is the idea of Hawking radiation, proposed by Stephen Hawking. Unlike the other methods, which involve extracting energy from rotation, this process involves quantum mechanics near the event horizon. Pairs of particles and antiparticles spontaneously appear due to quantum fluctuations. Normally, these pairs annihilate each other, but if one falls into the black hole while the other escapes, the black hole loses a small fraction of its mass. This slow evaporation could, in theory, be used as an energy source if a way to capture the escaping particles was developed. Although these ideas are fascinating, they remain theoretical. Extracting energy from black holes would require technology far superior to the current one. Even if it were possible, getting close enough to a black hole to install an energy extraction system would pose an extreme challenge due to its immense gravitational force and radiation. Even so, black holes represent an unexplored frontier in energy generation, and if humanity were to develop the means to harness them, they could provide almost unlimited energy. Level 60. Have you ever stood at the edge of a cliff, a tall building, or a train platform and felt a sudden, inexplicable urge to jump? Not because you really wanted to, but because for a fleeting moment your brain suggested that possibility to you. This disturbing and unsettling sensation is known as l'appel d'oid, which in French means the call of the void. It is an experience that many people have described, but it remains one of the most mysterious and least understood peculiarities of human cognition. Psychologists and neuroscientists have debated why this happens, and several theories attempt to explain it. One possibility is that a counterintuitive survival mechanism. Instead of being a suicidal impulse, it could actually be the way the brain reinforced the desire to stay alive by briefly simulating a dangerous action. The brain could be testing and strengthening your survival instinct. Basically, when you recognize a threat, your mind automatically considers an action related to it before rejecting it completely, making sure you remain cautious and safe. Another theory suggests that this phenomenon arises due to poor communication between different parts of the brain. The conscious mind, responsible for rational decision-making, may momentarily misinterpret the danger assessment made by the subconscious mind. When you recognize the potential danger, your brain quickly registers and recognizes the threat. But at some point in that process, the simple awareness of the danger is briefly misinterpreted as a suggestion to act accordingly. This could explain why people feel disturbed after experiencing the call of the void, as they know they have no desire to harm themselves, but their brain keeps producing that thought. Some researchers also relate this experience to intrusive thoughts, which are unwanted random thoughts that arise in our mind unexpectedly. Intrusive thoughts do not necessarily reflect a person's real desires, but rather strange glitches in cognitive processing, just as someone might suddenly think of saying something inappropriate in a quiet room without really wanting to. The call of the void could be another variant of this mental phenomenon. Although many people have felt this sensation, it is rarely found in scientific literature, so it remains largely unexplored. The exact mechanisms that trigger it remain unknown, making it one of the most mysterious peculiarities of human psychology. Whether it's a biological protection, a cognitive failure, or something completely different, the call of the void is a fascinating reminder that our minds are still full of secrets waiting to be revealed. Level 61. What if I told you that our entire universe, everything we know, could be inside a black hole? This might seem like science fiction, but some physicists believe it is possible. Let's analyze it. A black hole is a region of space where gravity is so intense that nothing, not even light, can escape. The boundary of a black hole is called the event horizon, and beyond it, we assume everything is crushed into a singularity, a point of infinite density. But what if that's not the whole story? Some theories suggest that when a massive star collapses and forms a black hole, instead of everything being crushed into a singularity, a new universe is created inside it. The idea is that the core of the black hole could bounce and take on a new form of space-time, creating a completely new reality on the other side of the event horizon. Physicists like Nikita Palsky have proposed that the Big Bang could have resulted from the formation of a black hole in a parent universe. In essence, each black hole could be the seed of a new universe, and our own cosmos could be inside one right now. The expanding universe behaves very similarly to objects falling into a black hole would experience time differently from the outside world. The laws of physics inside black holes are unknown, but they could allow the formation of new universes. If we were inside a black hole, could we ever get out? The event horizon would prevent anything from escaping back to the parent universe, so even if we were inside one, we could never prove it from the outside. Level 62. One of the most mind-boggling questions in modern science and philosophy is whether our universe is actually a computer simulation, a digital construction created by an advanced civilization. This idea, often referred to as the simulation hypothesis, suggests that reality, as we know, it could be an artificial illusion rather than a fundamental physical truth. The idea that reality is an illusion is not new. Philosophers such as Plato, with his allegory of the cave, and Dirt, who question whether we can trust our senses, have explored this question for centuries. However, the modern version of simulation theory was most famously proposed by Nick Bostrom, a philosopher from the University of Oxford, in his 2003 article, "Are You Living in a Computer Simulation?" Bostrom's argument is based on probability. He suggested that at least one of the following statements must be true. Civilizations never reach the level of technology needed to run realistic simulations. Advanced civilizations lose interest in running simulations of past human lives. We are almost certainly living in a simulation if advanced civilizations exist and can create highly realistic simulations. Then there could be billions or even trillions of simulated realities, making it statistically likely that we are inside one right now. Some scientists believe there are clues in physics that suggest our reality could be programmed. Space and time appear to be made of discrete units at the smallest scales, like pixels in a video game. The Planck length, the smallest unit of space with meaning, and the quantization of energy suggest that the universe may have a resolution limit similar to that of a digital screen. Quantum indeterminacy, the idea that particles do not have defined states until they are observed, is eerily similar to how video games only render what is needed in real time. The famous double-slit experiment suggests that reality behaves differently when observed, almost like a program that optimizes performance. The universe seems to be written in mathematical code. Max Tegmark, a physicist at MIT, suggests that reality is best understood as a mathematical structure, which could be a sign that it is a programmed simulation. Even scientists like James Gates have found error correction codes similar to those used in computers embedded in the equations of fundamental physics. If we are in a simulation, are there ways to check or escape it? Some propose to look for flaws in reality. If we detect inconsistencies in the laws of physics, it could be an indication that the universe is simulated. Others suggest finding the limits of computational capacity. A simulation would have processing restrictions, which would mean that the universe could have shortcuts or simplifications incorporated. Some even suggest performing deep computational experiments to see if reality behaves unexpectedly. Although the idea is fascinating, many physicists and philosophers disagree with the simulation hypothesis. There is no conclusive evidence that we are in a simulation, only thought experiments and patterns explainable in other ways. Simulating an entire universe with such complexity would require an immense amount of computational power, far beyond our conception. Even if physics could be simulated, how would we explain subjective experience and self-awareness? The simulation hypothesis is one of science's great unknowns. Although it remains speculative, it expands the limits of how we conceive reality, physics, and technology. If it is true, who or what created the simulation? If it is false, why does reality look so much like a computer program? For now, we may never know unless, of course, the simulation decides to reveal itself. Would you take the red pill or the blue one? Level 63. Could there be unknown quantum particles that influence human thought? Some researchers speculate that undetected quantum forces could subtly influence neuronal activity, decision-making, or even consciousness. While conventional neuroscience relies on classical physics to explain how the brain works, quantum mechanics introduces strange phenomena like entanglement and superposition, which could play a hidden role in cognition. It is already known that quantum effects influence biological processes, such as photosynthesis and bird navigation. So could something similar happen in the brain? If so, could this help explain intuition, hunches, or other inexplicable cognitive phenomena? The possibility that human thought is influenced by quantum-scale interactions remains a profound and speculative mystery. Level 64. In 1976, the NASA Viking probe performed a test to detect life on Mars. It mixed Martian soil with a nutrient solution containing radioactive carbon. The result was a strong release of gas, just like microbial metabolism on Earth. At first, it seemed that we had found extraterrestrial life, but then another test looking for organic molecules found nothing. NASA concluded that the reaction was due to the unusual chemistry of Mars, not life. Decades later, we discovered that Martian soil contains perchlorates, which could have destroyed any organic matter Viking was looking for. Some scientists now argue that Viking Eye could have detected life, but we dismissed it too soon. Did we unknowingly discover extraterrestrials almost 50 years ago? The mystery remains unsolved. Level 65. The WOW signal is one of the greatest unsolved mysteries in the search for extraterrestrial intelligence. Detected on August 15, 1977 by the Big Ear Radio Telescope of Ohio State University. This strange radio transmission lasted 72 seconds and originated in the constellation Sagittarius. The signal was so unusual that astronomer Jerry On, who was analyzing the data, marked it on the printout and wrote, "Wow," next to it, hence the name. What made the WOW signal extraordinary was its intensity and narrow bandwidth, resembling the type of signal an intelligent civilization could deliberately send. It was detected at a frequency of 1,420 megahertz, the exact frequency emitted naturally by hydrogen, the universe's most abundant element. Many scientists believe that if extraterrestrials were to send a signal, they might choose this frequency because of its universal significance. Despite extensive follow-up efforts, the WOW signal was never detected again. Scientists have searched the same region of space several times using more advanced equipment, but found nothing. Some have proposed natural explanations, such as comets emitting radio waves, but these theories remain controversial. The lack of repetition or a clear source means that, to date, no one knows what caused it. The mystery of the WOW signal continues to spark debate. Was it a transmission from an intelligent civilization, a strange cosmic coincidence, or simply an unknown natural phenomenon? Until we detect another similar signal, the answer will remain one of the most intriguing questions in science. Level 66. For centuries we have been asking ourselves one of the great questions. What is reality? At first it seemed simple. Reality was made of matter, small particles that formed everything we see. But as physics advanced, something unexpected was discovered. The deeper we went, the more it seemed that reality was not made of particles, but of something much stranger. At the heart of modern physics lies the quantum theory of fields, which tells us that each particle, each force, and each interaction is not just one thing, but a wave in an underlying field. The electron is not a small particle of matter, but an excitation in the electron field. Light is not just a particle called a photon, but a disturbance in the electromagnetic field. According to this view, the universe is not a collection of objects, but an intricate dance of invisible fields that shape everything around us. But if reality is made of fields, an even deeper mystery arises. Fields are not tangible things. We cannot touch, see, or measure them directly. They are abstract mathematical constructions that exist in space, vibrating, interacting, and giving rise to everything we perceive. So, if everything what we experience is only the result of disturbances in these invisible fields, does that mean that reality itself is nothing more than an illusion? And then there is the strangest part. Quantum fields do not stay there, waiting to be measured. In quantum mechanics, observation plays a key role in the determination of reality. A quantum particle exists in a superposition of possibilities until we observe it. The moment we measure it, the wave function collapses and a single result emerges. But before that, the system exists in a state of pure probability. Some interpretations suggest that quantum fields do not create reality by themselves. Only when an observer interacts with them does something defined emerge. In other words, the mere act of looking could be what gives rise to the universe. This idea, as disturbing as it may be, has given rise to some of the most radical interpretations in physics. Could consciousness itself be responsible for collapsing the wave function and turning potential into reality? If so, does that mean that reality does not exist without an observer? Or does reality already exist independently of measurement, waiting for us to understand it? The theory of quantum fields has provided us with the most accurate predictions in all of science, which has led to technologies such as semiconductors, lasers, and even our understanding of the forces of nature. However, at its core, it remains deeply mysterious. Do quantum fields create reality, or is there something even deeper hidden beneath them, waiting to be discovered? Level 67. Honeybees are incredibly intelligent for their tiny size. They can communicate, navigate over long distances, and even recognize human faces. But perhaps one of the most mind-blowing discoveries is that bees understand the concept of zero. That's right, one of the simplest and most abstract mathematical ideas, something that humans did not fully understand until thousands of years after we started counting, is understood by these tiny insects with brains smaller than a grain of rice. So how do we know? Scientists conducted experiments in which bees were trained to recognize quantities. They were shown sets of points, And when they correctly identified the smallest number, they were rewarded with something sweet. Over time, the researchers introduced an empty set, that is, one without points. Incredibly, the bees treated the empty set as a numerical value and correctly placed it in order, recognizing that 0 was less than 1. This may seem simple, but it is a major cognitive leap. 0 is an abstract concept. Most animals can distinguish between different numbers, but understanding that nothing is a number requires higher-order thinking. Before this experiment, only a few animals, such as primates and some birds, were known to understand the idea of 0. The fact that bees, with their tiny brains, can do it suggests that numerical understanding might not require a large brain at all. But why do bees need to understand 0? It could be useful for decision-making in their daily lives. If a flower has no nectar, it is better to avoid it rather than waste energy. Recognizing the absence of something as meaningful information could help bees optimize their foraging and survival strategies. This discovery raises even more important questions. If honeybees, with such limited neural hardware, can understand 0, does that mean that the ability to understand complex concepts has more to do with neural efficiency than with brain size? Could it mean that intelligence, or at least numerical reasoning, evolved independently in different branches of the animal kingdom? And here's something even stranger. The way bees process 0 is surprisingly similar to that of young children and even some primates. They have some difficulty distinguishing between 0 and 1, but they can easily differentiate larger numbers. This suggests that the way our brains and bee brains handle numerical concepts might be more similar than we ever imagined. The more we study bees, the more they surprise us. Their tiny brains seem to harbor an extraordinary cognitive capacity that challenges what we think we know about intelligence. If an insect can understand something as abstract as 0, what else might nature have discovered long before us? Level 68. The hypothetical particles that could travel faster than light. If they existed, they would violate some of the most fundamental principles of physics as we know it. But do they really exist, or are they just a mathematical peculiarity, an idea that seems interesting on paper but has no place in reality? To understand the tachyon, we have to go back to Einstein's theory of relativity. According to relativity, nothing with mass can reach or exceed the speed of light. The closer an object gets to the speed of light, the more energy it takes to keep accelerating it, and at the speed of light, it would take infinite energy. But tachyons, if they exist, would not start from rest and accelerate like normal particles, but would always travel faster than light. Here is the strange part. While normal particles gain mass as they approach the speed of light, tachyons would gain mass as they slow down. In other words, they could never slow down to the speed of light, just as we can never accelerate to it. This makes them behave in ways that seem strange, even paradoxical. If tachyons were real, they could theoretically send signals to the past, violating causality. This means that an effect could occur before its cause, breaking our normal understanding of time. Tachyons first appeared in theoretical physics through equations rather than observations. In 1967, the physicist Gerald Feinberg coined the term when he explored the mathematical possibility that there were particles that always moved faster than light. The equations work. There is nothing that directly prohibits them in mathematics. However, in the real world, no experiment has yet detected a tachyon. If they existed, they could constantly turn into other particles, which would make them impossible to directly detect. Some physicists have suggested that tachyons could be a sign of an unstable system, rather than a real physical particle. In quantum field theory, if a system predicts tachyons, it often means that the theory must be rewritten to eliminate them, much like how imaginary numbers appear in equations, but do not represent physical quantities in most cases. The idea has not been fully discarded. Some versions of string theory include tachyons, and scientists have speculated that they could play a role in the early universe. There have even been claims of experiments that detected tachyon-like effects in cosmic rays, but none have been confirmed. So, are tachyons real? For now, they remain purely theoretical. They are allowed by certain mathematical frameworks, but there is no solid evidence that they actually exist. If they existed, they could rewrite our understanding of time and causality. But until we find them, they remain one of the many fascinating mysteries on the frontiers of physics, an idea that may be too strange for reality to allow. If they existed, they could rewrite our understanding of time and causality. But until we find them, they will remain one of the many fascinating mysteries on the frontiers of physics, an idea that may be too strange for reality to allow. Level 69. What is the true shape of the universe? It might seem like a simple question, but the answer is anything but. The universe is not something we can go out and observe. It is a vast, possibly infinite expanse shaped by the laws of physics. According to Einstein's theory of general relativity, space itself curves and stretches depending on the mass and energy it contains. This means that the universe could have one of three possible shapes: flat, spherical, or saddle-shaped. If it is flat, traveling in a straight line would be possible forever. If it is spherical, space would curve in on itself, meaning that you could eventually return to the starting point. If it is saddle-shaped, space would warp outward in strange ways. Measurements of the cosmic background radiation suggest that the universe is extremely flat, but that does not rule out curvature on a scale too large for us to detect. Some theories even suggest that the universe could have the shape of a donut with loops that surpass human intuition. And then there is the possibility that the universe has no shape at all, that space extends infinitely, or that it is part of a higher dimensional structure we cannot understand. We may never know for sure, but as we delve deeper into our understanding of physics, we are slowly getting closer to unraveling the ultimate shape of reality itself. Level 70. Cosmic filaments are among the largest structures in the universe and form vast spiral-shaped patterns that stretch for billions of light years. These filaments are composed of galaxies, dark matter, and hot gas, creating an intricate network that connects clusters of galaxies like the threads of a cosmic web. But why do these filaments exist? What fundamental forces and principles shape the universe into this grand design? The answer lies in the early moments after the Big Bang, when the universe was young and almost uniform, with only small variations in density. However, gravity caused these small fluctuations to grow over time. Areas with a little more mass attracted the surrounding matter, creating dense regions that would later form galaxies and clusters of galaxies. Meanwhile, the less dense areas emptied, forming cosmic voids. This process, driven by gravity and dark matter, shaped the universe into a vast, network-like structure. Dark matter plays a crucial role in this formation. Although invisible, the gravitational influence of dark matter helps guide the movement of ordinary matter, attracting it to filaments over billions of years. Simulations of the evolution of the universe show that, as galaxies and gas flow along these filaments, they are channeled into massive nodes, regions where clusters of galaxies form. Filaments act as bridges that channel matter from one part of the universe to another. The filaments themselves are immense, sometimes extending hundreds of millions of light years. Despite their immensity, they are surprisingly thin compared to the dense clusters of galaxies at their intersections. They also contain a significant portion of the missing matter in the universe. Scientists estimate that much of the unaccounted for ordinary matter exists in the form of diffuse gas within these filaments, making them crucial to understanding the total composition of the cosmos. Observing cosmic filaments is quite a challenge, since, unlike galaxies, which shine brightly, filaments are mostly composed of tenuous gas and dark matter. However, astronomers have detected them by observing how the light from distant galaxies interacts with the gas inside. Some filaments have even been seen through weak gravitational lensing, where their mass slightly deflects the light from background objects. One of the biggest unanswered questions is whether cosmic filaments influence the evolution of galaxies. Some theories suggest that filaments act as highways that direct galaxies and intergalactic gas along specific paths. This movement could determine how galaxies form, merge, and grow over time. Some evidence suggests that galaxies born within filaments have different properties than those in isolated regions. Cosmic filaments challenge our understanding of large-scale structure formation and the interaction between dark matter, gravity, and ordinary matter. Although the simulations provide clues, the exact mechanisms that govern their formation and influence remain unknown in cosmology. As telescopes become more advanced, scientists hope to unravel more details about these enigmatic structures, shedding light on the cosmic web that shapes the universe. Level 71. Time travel. It is one of the most fascinating concepts of both science and fiction. But is it really possible? Scientists have debated this question for decades, and although we have not yet built a working time machine, physics suggests that it may not be entirely impossible. Let's start with Einstein's theory of relativity. According to special relativity, time slows down the faster you move. If you were to travel at a speed close to that of light, time would pass much more slowly for you compared to someone who stayed on Earth. This is called time dilation and has been experimentally confirmed using high-speed particles and atomic clocks on airplanes. So, in a way, we already know that traveling to the future is possible, but not in a useful way for human beings. But what about traveling to the past? That's where things get complicated. Einstein's general theory of relativity suggests that massive objects curve space-time and, in extreme cases, could create closed time-like curves, a theoretical way to go back in time. Some physicists have proposed that rotating black holes or wormholes could allow travel back in time. A wormhole, if it existed, could theoretically connect 2 points in space-time, allowing someone to jump between different eras. However, no evidence has been found that natural wormholes exist, and even if they did, keeping them stable would require something called exotic matter, a form of matter with negative energy that we still don't know how to create in large quantities. There's also the problem of paradoxes. The most famous is the grandfather paradox. If you travel back in time and prevent your grandfather from meeting your grandmother, you would never have been born, which means you could not have traveled back in time in the first place. Some theories try to resolve this paradox, such as the many-worlds interpretation of quantum mechanics, which suggests that each time travel would create an alternative timeline instead of changing the past in our own universe. Then there is the Novikov self-consistency principle, which suggests that if time travel is possible, events must align in such a way that paradoxes are avoided, which means that, regardless of what is done in the past, the timeline would correct itself to ensure consistency. For example, if you tried to prevent a historical event from happening, something else would intervene to ensure that it still took place. So where does this leave us? While traveling to the future is technically possible under extreme conditions, traveling to the past remains deeply uncertain. The laws of physics do not outright prohibit it, but we would need new advances in quantum mechanics, exotic matter, or wormhole physics to make it work. Until then, time travel remains one of the greatest scientific mysteries, one that may take centuries or even a new understanding of physics to unravel. Would you travel to the past or the future if you had the opportunity? Let's continue the debate in the comments. Level 72, Ghost DNA, is one of the strangest and most controversial mysteries of modern science. The idea comes from experiments conducted in the 80s and 90s by the Russian scientist Vladimir Poynin, who claimed to have discovered a phenomenon by which DNA appears to leave a footprint in empty space even after the physical DNA has been removed. The experiment consisted of placing DNA molecules inside a vacuum chamber and passing a laser through them to observe how the light was scattered. As expected, the DNA caused predictable changes in the light pattern, but what was truly strange occurred when the DNA was removed. Instead of the light scattering pattern returning to normal, the pattern that had been influenced by the DNA remained as if the DNA were still there. This effect, which Palpin called the DNA ghost effect, suggested that, in some way, the space where the DNA had been retained a memory of its presence. This discovery raised profound questions about the nature of reality. How could something that was no longer physically present continue to influence the environment? Was this evidence of a new physical phenomenon, or was it some unknown property of quantum fields? Some have speculated that this could be related to how information is stored in the fabric of space, a concept that echoes ideas from quantum mechanics and holographic universe theories. Despite its fascinating implications, ghost DNA has remained on the fringes of science. The effect has not been widely replicated by mainstream scientists, and many believe the results could be due to experimental errors or misinterpretations. Critics argue that, without independent confirmation, the findings remain, at best, speculative. However, if the effect were real, it would force us to rethink fundamental ideas about biology, quantum physics, and even consciousness. In essence, the mystery of ghost DNA touches on one of the great questions of science. Is reality made up solely of physical matter, or does an invisible structure of space itself exist that can contain information? If such a footprint were possible, it could point to mechanisms beyond our current understanding, potentially linking biology to deeper physical laws that we have not yet discovered. Whether ghost DNA turns out to be a revolutionary discovery or an illusion, it remains one of science's strangest unsolved mysteries. Scientific Level 73. Interstellar objects like Oumuamua are among the most intriguing mysteries of modern astronomy. Unlike comets or asteroids in our solar system, these objects originate in deep space beyond the influence of our sun. Oumuamua, discovered in 2017, was the first confirmed interstellar object to pass through our solar system, and its strange behavior perplexed scientists. The big question is how such an object could have formed and why it seems so different from typical comets or asteroids. Most known space rocks follow predictable patterns. Asteroids are dense, rocky bodies, while comets contain ice that sublimates into a tail as they approach the sun. However, Oumuamua didn't behave like either of them. It didn't have a visible tail similar to that of a comet, even when it passed at high speed in front of the sun, and its shape seemed unusually elongated, more like a cigar or a thin pancake than a typical space rock. One possibility is that Oumuamua was a fragment of the violent breakup of a planetesimal, a small planetary body that formed in another star during its journey through space. The tidal forces of a larger planet or star could have stretched it into its unusual shape before launching it from its natal system. Some researchers suggest that it could be a fragment of frozen nitrogen similar to the surface of Pluto, which would explain why it looked like a comet but lacked a visible tail. Another hypothesis is that it could have been a hydrogen iceberg, a rare form of icy body that sublimates pure hydrogen, making it invisible to our telescopes. This would explain why Oumuamua appeared to accelerate slightly as it left the solar system, an effect commonly observed in comets, but without the visible emission of gases. Perhaps the most controversial idea is that Oumuamua was an artificial construction, possibly an abandoned probe or light sail from an alien civilization. This idea gained strength from the object's inexplicable acceleration and unusual shape, which some scientists argued was consistent with a thin reflective sail pushed by starlight. Although most astronomers reject this explanation in favor of natural processes, the fact is that Oumuamua did not perfectly fit into any known category of space objects, unlike typical asteroids and comets. Oumuamua was already moving at an extremely high speed when it entered our solar system, meaning it could not have originated within it. Its speed and trajectory indicated that it was simply passing by, with no possibility of return. This suggests that interstellar objects could be more common than we thought, drifting in the void after being expelled from their systems of origin. One of the challenges to solving the mystery of Oumuamua is that it was only visible for a brief period. When astronomers realized how unusual it was, it had already passed the closest point to the sun and was rapidly fading from view with no possibility of sending a probe or collecting more detailed observations. Its true nature remains uncertain, but with future telescopes such as the Veris C. Rubin Observatory, which is expected to detect more interstellar objects, scientists hope to learn more about how these mysterious travelers form and what they can tell us about planetary systems beyond our own. Whether Oumuamua was a fragment of a destroyed world, a strange hydrogen iceberg, or something else, a new chapter opens in the study of objects beyond our solar system. Level 74. What is the most fundamental particle at the heart of physics? The search for the most basic components of reality. Scientists have long sought the smallest and indivisible pieces of a universe, the ultimate components of matter and energy. But as we delve deeper into the fabric of existence, the answer becomes more elusive. For centuries, atoms were thought to be the smallest units of matter, but the discovery of protons, neutrons, and electrons in the early 20th century shattered that notion. Then, physicists discovered that even protons and neutrons were made up of quarks held together by the strong nuclear force. Electrons, on the other hand, appear to have no internal structure, making them leading candidates for being fundamental. The standard model of particle physics, the best framework we have for understanding the subatomic world, proposes a set of fundamental particles: quarks, leptons, which include electrons, and force carriers, such as photons and gluons. According to this model, quarks and leptons are indivisible. They have no known substructure. However, some theories suggest that quarks and leptons may not be fundamental after all. String theory, for example, proposes that all force carriers, such as photons and gluons. According to this model, quarks and leptons are indivisible and have no known substructure. However, some theories suggest that quarks and electrons may not be fundamental after all. String theory, for example, proposes that all particles are actually tiny vibrating strings of energy with different modes of vibration that give rise to different particles. If string theory is correct, then the most fundamental entity is not a particle, but a one-dimensional string. To complicate matters even more, physicists have long sought a deeper unification of forces and particles. Some have proposed that particles could emerge from even more fundamental entities, perhaps energy fluctuations in a deeper quantum field or structures within a higher dimensional space. The idea that space and time themselves could be made of something more fundamental is gaining ground in theoretical physics. So, what is the most fundamental particle today? Quarks and electrons are the best candidates, as they have no known size or structure and are treated as points in our best theories. But history shows that every time we think we've reached the bottom, nature surprises us with another layer. The search for the true foundation of reality continues. Level 75. Does the soul exist? This question has fascinated philosophers, scientists, and theologians for millennia. But what does science really say about the soul? Most religious traditions describe the soul as an immortal, non-physical essence that exists independently of the body. It is often considered to be the source of consciousness, personality, and identity. However, from a scientific perspective, things become much more complicated. The field of neuroscience tells us that everything we experience, our thoughts, emotions, memories, and even our sense of self, arises from brain activity when neurons connect in certain patterns. We feel love, pain, curiosity, or fear. When the brain is damaged, a person's personality or memories can change. If consciousness and identity are so closely linked to the physical brain, what space is left for an independent soul? But some argue that science has not explained everything. Certain near-death experiences describe people recounting vivid encounters with the afterlife or seeing things they shouldn't be able to see while clinically unconscious. Although skeptics attribute these experiences to brain chemistry, others suggest that they point to something beyond material existence. Quantum physics adds another layer of mystery. Some researchers speculate that consciousness could be rooted in the fundamental structure of reality itself. Theories such as quantum consciousness propose that our minds could be connected to quantum processes that extend beyond the body. Could this be a scientific basis for what we call the soul? Despite centuries of debate, there is no definitive evidence in either direction. The question of whether the soul exists remains one of the greatest mysteries of science, one that may never have a concrete answer. However, as we delve into our understanding of consciousness, perhaps someday we will discover that the answer is much stranger than anyone could imagine. Level 76. The Great Attractor is a mysterious gravitational anomaly that attracts entire galactic clusters, including the Via Lactea, at a speed of more than 600 kilometers per second. But what is it and why can't we see it? It is located about 150 to 250 million light-years away in the zone of avoidance, a region obscured by the dense stars and dust of our galaxy, which makes it invisible to optical telescopes. But radio and X-ray observations reveal a huge concentration of galaxies, including the Norma cluster, which exerts an immense attraction. However, the Great Attractor may not be the final destination. Beyond is the Shapley supercluster, an even more massive structure that attracts us. Whether it is a dense region of galaxies, dark matter, or something new in physics, the true nature of the Great Attractor remains one of the greatest cosmic mysteries. Level 77. Imagine looking at the night sky and realizing that our universe could be just one of many. What if beyond what we can see there were countless universes, each with its own stars, galaxies, and even different laws of physics? One reason scientists consider this is cosmic inflation, the theory that the universe expanded rapidly after the Big Bang. Some versions suggest that different regions of space-time formed bubble universes, each separate from ours. Then there is the quantum multiverse, where each quantum event creates a new universe. According to this view, there is a universe in which you made a different decision this morning, another in which dinosaurs still roam, and many more. String theory adds another possibility: higher dimensions where other universes exist parallel to ours, invisible but just as real. Some even speculate that we could be in a simulation with many more simulated universes coexisting with ours. So, how many universes exist? The truth is that we don't know. It could be just one, none, or infinite beyond what we can measure. If the multiverse is real, somewhere another version of you is watching this video and asking the same question. Level 78. Throughout history, human beings have dreamed of immortality. But can science make it a reality? One approach is biological immortality, stopping or reversing aging. Some creatures, such as the Turritopsis dohrnii jellyfish, can regenerate indefinitely. Scientists are exploring telomere extension and genetic modification to slow down aging, but ethical and biological challenges remain. Regenerative medicine offers another path. Stem cell therapies and laboratory-grown organs could replace damaged tissues, potentially prolonging life indefinitely. Meanwhile, some futurists suggest mind uploading, that is, transferring consciousness to a digital medium, although this is far from reality. Rapid advances in brain-computer interfaces make it an intriguing possibility. Even if we achieve immortality, should we do it? A life without end could bring challenges such as boredom, overpopulation, or new ethical dilemmas. As science advances, true immortality remains one of humanity's greatest mysteries. Intelligence has shaped the world as we know it, but what will ultimately happen to it? Will it continue to evolve, or will it come to an inevitable end? If intelligence continues to advance, it could extend beyond Earth, adapting to new environments and even merging with technology. Some scientists speculate that artificial intelligence could surpass human intelligence, leading to a new era in which biological and artificial intelligence would merge. This could create a form of consciousness that would no longer depend on physical bodies, existing purely as data or energy, capable of exploring the universe indefinitely. However, intelligence could also have limits. Civilizations could destroy themselves before reaching an advanced state, whether through war, environmental collapse, or uncontrolled AI. Even if intelligence survived, the universe itself is not eternal. If the universe expands forever and experiences heat death, all energy will be lost, making any form of intelligence impossible. Another possibility is that intelligence finds a way to escape the limits of this universe, altering its own nature or even creating new realities. Some theories suggest that intelligence could play a role in shaping the future of the cosmos, becoming something beyond our current understanding. For now, the ultimate fate of intelligence remains unknown. whether it will thrive, evolve into something unimaginable, or fade away completely. It is one of the deepest mysteries we face. Level 80. All our experience of reality is shaped by three spatial dimensions: length, width, and height. But why do we perceive the world this way? Could there be more dimensions beyond our perception? One reason is biological. Our eyes and brain work together to interpret depth using signals, such as perspective, movement, and stereoscopic vision provided by our two eyes. This gives us a three-dimensional understanding of space that allows us to move through the world effectively. Evolution likely favored organisms that could perceive depth, as it helped them survive, hunt, avoid predators, and understand distances. Physics also suggests that the three dimensions could be fundamental to the functioning of the universe. In three-dimensional space, gravity and electromagnetic forces work in such a way that allows stable planetary orbits, formation of complex structures, and even the appearance of life. If we lived in two dimensions, physics as we know it would not function in the same way. But what if there were more than three dimensions? String theory proposes that additional dimensions exist, but they're rolled up at microscopic scales too small for us to perceive. Some physicists believe that higher dimensional spaces could explain mysteries, such as dark matter or the true nature of gravity. Our perception of the three dimensions could be just a limitation of human senses. If higher dimensions exist, it is possible that we will never experience them directly, but their effects could shape the universe in ways that we still do not understand. Level 81. Quantum gravity is one of the greatest unsolved mysteries in physics. Our current understanding of reality is based on two pillars: general relativity, which explains gravity on a large scale, and quantum mechanics, which governs the smallest particles. However, these two theories do not quite fit together. General relativity describes gravity as the curvature of space-time, while quantum mechanics suggests that everything, including gravity, is made up of small, discrete units. The problem is that no one knows what those fundamental units of gravity are or how they might behave. Many physicists believe that space and time themselves could be quantized, meaning they come in small, indivisible fragments at an unimaginably small scale called the Planck length. Some theories suggest that gravity is carried by a hypothetical quantum particle called a graviton, but no experiment has yet detected one. String theory proposes that all particles, including gravitons, are small vibrating strings instead of points, but there is no direct evidence for this. Another approach, loop quantum gravity, suggests that space-time is woven from small loops, giving it a discrete structure instead of being smooth and continuous. Despite these ideas, no theory of quantum gravity has yet been proven. One challenge is that gravity is incredibly weak compared to other forces, making its quantum effects almost impossible to detect. Another problem is that black holes seem to break all our current rules, according to which quantum mechanics says information must always be preserved. Black holes seem to erase it completely, leading to what is known as the black hole information paradox. If we could decipher the mystery of quantum gravity, we could discover a completely new understanding of the universe, perhaps even revealing what happens inside black holes or what existed before the Big Bang. But for now, the true nature of gravity at the quantum level remains one of the greatest mysteries of physics. 82. Why does anything exist at all? This is one of the deepest mysteries of both science and philosophy. If nothing had ever existed, neither the universe, nor space, nor time, there would be no one to question it. But instead, here we are, living in a vast and complex cosmos. Why do some physicists suggest that nothingness could be unstable in quantum mechanics? Empty space is not really empty, but full of virtual particles that appear and then disappear. If the universe arose from a quantum fluctuation, that could mean that nothing was truly possible in the first place. Another theory suggests that the laws of physics require something to exist. Some equations suggest that a total balance between positive and negative energy could lead to a universe in which the net energy was zero, meaning that something could arise without violating the fundamental laws. Others speculate that the universe exists simply because it had to. Certain interpretations of physics suggest that, given the infinite possibilities, a universe like ours would inevitably form. Some even argue that all possible universes exist in a vast multiverse, and we're simply in one in which things have turned out this way. But even if physics explains how the universe arose, it does not necessarily answer the question of why. The question of existence can go beyond science and touch the very limits of human understanding. For now, why there is something instead of nothing remains one of the deepest mysteries of all time. Level 83. Black holes are some of the most mysterious objects in the universe, places where gravity is so strong that nothing, not even light, can escape, but deep down beyond the event horizon lies something even stranger, a singularity. A singularity is a point of infinite density where the known laws of physics simply break down. If we could see a singularity directly, it could reveal secrets about the nature of space-time and even the fundamental structure of reality. This is where the cosmic censorship hypothesis comes into play, proposed by physicist Roger Penrose, which suggests that singularities should always be hidden behind event horizons, meaning the universe hides them from view. Naked singularities, points of infinite density exposed to the outside universe, should not exist. If this hypothesis is correct, black holes act as cosmic safety nets that ensure the chaotic collapse of physics remains hidden from the rest of the cosmos. But what if the hypothesis is actually wrong? Some theoretical models suggest that, under certain conditions, a singularity could be exposed, thus violating cosmic censorship. If naked singularities existed, they could challenge our understanding of general relativity and even provide clues for a deeper theory of quantum gravity. They could behave unpredictably, distorting time and space in ways we cannot yet fully understand. So far, no naked singularities have been observed, but scientists continue to test the limits of this idea. If the cosmic censorship hypothesis is true, the universe makes sure the deepest mysteries of physics remain hidden behind the event horizons of black holes. But if it is not, we may be about to discover a completely new facet of reality, in which the fundamental rules of the universe would be exposed for all to see. In our everyday experience, objects exist in only one place at a time. A chair stays where it is. A person cannot be in two places at once. But in the strange world of quantum mechanics, particles do not follow the same rules. Electrons, photons, and other tiny particles can exist in multiple places at the same time, a phenomenon known as quantum superposition. This idea was famously demonstrated in the double-slit experiment. When a single particle, such as an electron, is sent towards a barrier with two slits, it does not pass through only one or the other, but behaves as if it passes through both simultaneously. The particle exists in a superposition of states that interfere with each other, as if it were in two places at once. Only when observed, it chooses a location and collapses into a single result. But how does this really work? One interpretation suggests that particles exist in multiple places until measurement forces them into a defined position. Another idea, the many worlds interpretation, proposes that each possible location exists in a separate, branched reality. According to this point of view, instead of the particle being in two places at once, the universe itself is divided into different versions, each of which contains a particle in a different place. Despite decades of experiments, the true nature of quantum superposition remains a mystery. Scientists continue trying to understand if this strange behavior is a fundamental aspect of reality or just a limitation of how we observe the quantum world. If we unlock the full potential of quantum mechanics, it could revolutionize everything from computing to teleportation. For now, particles defy our everyday logic and question our understanding of what it means to be in one place. Level 85. For centuries, scientists have searched for a single theory that explains everything in the universe, a great unified theory. At this moment, physics is based on two powerful but separate frameworks: general relativity, which describes gravity and the large-scale structure of the universe, and quantum mechanics, which governs the subatomic world. Both work incredibly well in their own areas, but they contradict each other at extreme scales, such as inside black holes or at the Big Bang. A true unified theory would bridge this gap and unify all the fundamental forces of nature into a single equation. One of the main candidates is string theory, which proposes that everything in the universe is made of tiny vibrating strings instead of point particles. This theory suggests that there are additional dimensions beyond the three known ones of space and one of time, which could resolve the contradictions between relativity and quantum mechanics. Another approach is loop quantum gravity, which attempts to quantize space and time themselves. Both ideas remain unproven and difficult to test, since they operate at energy scales far beyond our current technology. Physicists have already unified three of the four fundamental forces: electromagnetism, the weak nuclear force, and the strong nuclear force in a single framework. However, gravity remains the exception that resists all attempts at unification. If a theory of grand unification existed, it could answer some of the deepest questions in physics, such as what happens inside black holes, what existed before the Big Bang, and whether the laws of the universe are truly fundamental or only emergent from a deeper reality. Despite decades of effort, no one has found the definitive equation that explains everything. Some wonder if such a theory really exists, or if nature is simply too complex to be reduced to a single formula. The search for a grand unified theory continues to drive the understanding of the deepest mysteries of the cosmos. Level 86. Consciousness is one of the greatest mysteries of science, but could it really shape reality? Some interpretations of quantum mechanics suggest that it could. In experiments like the double-slit experiment, particles behave differently when they are observed, as if the act of measuring changes their state. This has led some to question whether consciousness plays a fundamental role in shaping the physical world. Some physicists argue that this idea is a misunderstanding of quantum mechanics, that observation simply means interaction with a measuring device, not human consciousness, but others believe there could be a deeper connection. Theoretical models, such as the participatory universe, proposed by physicist John Wheeler, suggest that consciousness and the act of observation may be essential to giving existence to reality. Beyond physics, studies in psychology and neuroscience suggest that consciousness influences reality in more subtle ways. The placebo effect, for example, shows that belief alone can produce real biological changes in the body. If consciousness has the power to shape reality, even in small ways, it could challenge everything we think we know about the universe. Could the mind have a role in shaping matter, time, or even the laws of physics? Or is consciousness just a passive observer in an indifferent universe? Science continues to seek answers, but the possibility that our consciousness is linked to the fundamental fabric of reality is one of the most intriguing mysteries of all. Level 87. We experience the world in three spatial dimensions: length, width, and height, plus time as a fourth dimension. But could there be more? Some theories of physics suggest that higher dimensions exist, although we cannot perceive them directly. One of the main ideas comes from string theory, which proposes that the fundamental components of the universe are not tiny particles, but vibrating strings of energy. For the mathematics that underpins string theory to work, additional dimensions are needed, often 10 or 11 in total. These additional dimensions could be rolled up so small that they're imperceptible to us, hidden within the fabric of space itself. Another reason why physicists suspect that higher dimensions might exist is that, compared to other fundamental forces, gravity is extremely weak. Some theorists suggest that this is because it leaks into higher dimensions, which would explain why it seems much weaker than electromagnetism or nuclear forces. If higher dimensions exist, could we ever detect them? Scientists are looking for clues in particle physics experiments, such as those at the Large Hadron Collider, which could reveal evidence of additional dimensions through unusual interactions between particles. Some also believe that cosmic phenomena, such as black holes or gravitational waves, could offer clues about dimensions beyond those we know. If we could access these higher dimensions, it could revolutionize our understanding of reality. Some even speculate that advanced civilizations, if they exist, may already be using higher dimensions to travel or communicate in ways that we cannot yet understand. For now, the existence of higher dimensions remains an unsolved mystery. But if they are real, they could be the key to unlocking the deepest secrets of the universe. Level 88. Deep within quantum mechanics lies a strange and disturbing question. Does the universe need an observer to exist? The foundations of quantum theories suggest that particles do not have defined properties until they are measured. Before observation, they exist in superposition, here and there, this and that, in a diffuse nebula of possibilities. But the moment we look, the wave function collapses, and reality solidifies into a single result. This raises an even deeper mystery. If observation is what defines reality, what happens in the absence of an observer? Does the universe only exist because something conscious, measurement, or some unknown force is constantly observing? The famous thought experiment of Schrödinger's cat illustrates this dilemma. A cat in a box connected to a quantum event remains alive and dead until observed. But who or what counts as an observer? Some physicists argue that consciousness itself plays a key role in shaping reality, an idea that borders on philosophy. Others believe that observation is simply the result of interactions with the environment, a concept known as decoherence, in which particles interact with their environment, causing their states to appear defined. But even this explanation leaves questions unanswered. If everything was entangled at the beginning of the universe, does that mean that reality only became real when the first observer emerged, whoever or whatever it was? This mystery leads to strange possibilities. Could the universe itself be conscious in some way? Could reality be an illusion created by observation? Is there a deeper, hidden layer of physics that explains why things seem definitive? Until we answer these questions, we may never really know if the universe exists independently or only when someone observes it. Level 89. The human mind is one of science's greatest mysteries, and some researchers believe that quantum mechanics could be the key to understanding consciousness. This idea, known as the quantum mind hypothesis, suggests that consciousness arises not only from classical brain processes, but from quantum phenomena that take place at microscopic level within neurons. One of the best-known theories in this field comes from physicist Roger Penrose and anesthesiologist Stuart Hameroff. They propose that tiny structures within brain cells called microtubules could act as quantum computers that process information in ways that go beyond classical physics. If this were true, it could explain why human thought and decision-making feel so different from artificial intelligence or conventional computing. But there is a problem. Quantum effects are extremely delicate, and they usually require temperatures close to zero to be observed. The human brain is warm and full of chaotic biological activity, which should make quantum coherence impossible. However, some experiments suggest that quantum processes may still play a role in biology, from photosynthesis to bird navigation, suggesting that life itself could harness quantum mechanics in unexpected ways. If consciousness arises from quantum processes, it could mean that the mind is more than just a biological machine. It could be accessing deeper aspects of reality. Some even speculate that this could offer insight about free will, creativity, or even life after death. However, the quantum mind hypothesis remains controversial, and many neuroscientists argue that classical physics is sufficient to explain consciousness. For now, the mystery remains whether the mind is purely a product of neurons or is connected to the quantum world. It is one of the deepest and most unanswered questions of science. Level 90. What happens to consciousness after death? It is one of the deepest and most disturbing mysteries of existence. Science tells us that when the body dies, brain activity ceases, and with it the conscious experience we associate with being alive. But does consciousness simply disappear, or could it persist in some form beyond the body? Many neuroscientists argue that consciousness is a pure product of brain activity. When neurons stop firing, the self dissolves, just like a computer that shuts down when it runs out of power. From this perspective, death is definitive, an irreversible state of nothingness. However, others believe that consciousness could be something more than simple brain activity, possibly a fundamental aspect of the universe itself, interwoven into the fabric of reality in ways we do not yet understand. Near-death experiences have fueled the debate. Thousands of people who have been clinically dead for minutes or even hours have reported vivid experiences, such as floating above their bodies, seeing a tunnel of light, or meeting deceased loved ones. Some describe a profound sense of peace or an expanded awareness beyond space and time. While skeptics attribute these experiences to lack of oxygen, neurotransmitter spikes, or hallucinations caused by a dying brain, others wonder if these experiences suggest that consciousness can exist independently of the body. Quantum physics has also entered the debate. Some researchers propose that consciousness may not be a mere byproduct of brain function, but may have a quantum basis. Theoretical physicist Roger Penrose and anesthesiologist Stuart Hameroff developed the theory of orchestrated objective reduction, which suggests that consciousness arises from quantum processes within the microtubules of brain cells. If consciousness is linked to quantum states, some speculate that it could persist in a different form after death, dispersing into the universe rather than ceasing to exist altogether. Religious and spiritual traditions have long offered answers, from the idea of reincarnation to eternal life in a spiritual realm. Some belief systems describe consciousness as an energy that continues its journey after death, whether as a reincarnated soul, a spirit in another dimension, or a force that merges back into the cosmos. Although these ideas provide comfort to many, they remain unproven by scientific standards. Ultimately, the fate of consciousness remains an open question, sitting at the intersection of science, philosophy, and personal beliefs. While current research suggests that consciousness depends on the brain, there are still mysteries about the nature of consciousness that science still has to unravel. Whether consciousness is extinguished with death or continues in ways we cannot yet measure remains one of the greatest unknowns of human existence. Level 91. Some scientists and philosophers propose that reality is not made of matter or energy in its essence, but of something even more fundamental: information. This idea suggests that everything we experience, from physical objects to consciousness itself, arises from an underlying informational structure very similar to the data in a vast computational system. Could the universe be processing reality like a giant quantum computer? This idea is inspired in part by quantum mechanics, where particles do not appear to have defined properties until they are observed, but exist in multiple simultaneous states governed by probabilities. Some interpretations suggest that reality does not really exist in a physical sense until it is measured, as if the universe processed the information when it needs it, similarly to how a video game only shows what the player sees. Another clue comes from black holes. Black holes. Physicist Stephen Hawking discovered that black holes emit radiation and gradually shrink, leading to the paradox of what happens to the information of everything that falls inside. Modern theory suggests that, instead of disappearing, this information is somehow preserved on the event horizon, as if space were a kind of storage medium. This has given rise to ideas such as the holographic principle, which proposes that our three-dimensional universe is actually encoded on a two-dimensional surface at the cosmic edge, turning reality into a projection of pure information. Even the equations of physics point to this idea. The laws that govern the universe, from relativity to electromagnetism, can often be described in terms of information flow rather than physical properties. Some researchers believe that space, time, and even mass could arise from information interactions on the smallest scale. So they're sometimes called ITB, a term coined by physicist John Wheeler that suggests that reality arises from fundamental choices, like the bits of a computer. If reality is ultimately information, what does that mean for consciousness? Some theories suggest that our own consciousness could be part of this informative structure rather than separate. This raises stranger questions. Could reality itself be a kind of simulation? If information is the basis of everything, does that mean the universe was programmed somehow? Could our experience of reality be more like a process running on an unimaginably vast computational framework? While these ideas remain speculative, they challenge our deepest assumptions about what is real. If information is the true basis of the universe, understanding it could redefine the nature of existence. Level 92. Nothing seems simple, but the more you explore, the stranger it becomes. In everyday life, we think of nothing as an empty space, a void where something was before, but in physics, true nothing does not seem to exist, not even in the vacuum of space, where particles appear and disappear. Existence due to quantum fluctuations. The fabric of reality itself is never empty. Philosophers have also struggled with this concept. If nothing is the absence of everything, then it should not exist. But if it does not exist, why is there something instead of nothing? Some argue that nothing is just a human construct, a way of describing absence, not a state of reality. In cosmology, the nature of nothing is linked to the origins of the universe. Some theories suggest that the universe arose from a quantum vacuum where spontaneous fluctuations created matter and energy. But if the laws of physics allowed this, was there really nothing at the beginning? Even mathematically defining nothing is complicated. In set theory, the empty set is still something, a collection that contains no elements. Zero exists as a concept, but is not the same as non-existence. So, does true nothing exist, or is it just an illusion, an impossible state that our universe never reaches? Science, philosophy, and mathematics point to a strange conclusion. The very idea of nothing could be meaningless. Physics has done an incredible job explaining the universe, from gravity to quantum mechanics, but could there be a fundamental law we have not yet discovered? All great scientific revolutions have arisen from discovering something unexpected. Newton's laws explain motion, but could not account for extreme velocities or the deeper nature of gravity, which Einstein's relativity later addressed. Quantum mechanics then revealed a strange probabilistic world at tiny scales, but remains incompatible with relativity. Scientists have been looking for a unified theory that connects everything, but so far, no theory of everything has been confirmed. There are indications that something is missing. Dark matter and dark energy make up 95% of the universe, but we still do not know what they are. Anomalies in cosmic expansion, unexplained fluctuations, and fundamental constants, and a mystery of why the universe seems to be finally adjusted for life, suggest that our current understanding may be incomplete. Some physicists propose additional dimensions, hidden particles, or even a completely new force of nature. Experiments at the Large Hadron Collider and deep space observations could provide the breakthrough if we discover particles that do not fit the standard model or find inconsistencies in the laws of gravity at extreme scales, which could point to an unknown law governing reality. Until then, the possibility remains one of science's greatest mysteries. Level 94. The Big Bang Theory explains how the universe expanded from an incredibly dense and hot state, but leaves unanswered one of the greatest mysteries. What was there before? One possibility is that time itself began with the Big Bang, meaning that before makes no sense in this view. Space and time emerged together, and asking what was there before is like asking what is north of the North Pole. Another idea is that of the cyclic universe, in which the cosmos expands and contracts endlessly. Some theories suggest that a previous universe collapsed into a big crunch, triggering a new Big Bang. This would mean that our universe is only the last in an infinite series. Quantum mechanics also offers strange possibilities. The universe could have arisen from a quantum fluctuation in a timeless vacuum. According to this view, small quantum instabilities could have led to the spontaneous formation of space-time. Another theory is that of the multiverse, according to which our Big Bang was only one event in an eternal landscape of universes. Some physicists propose that new universes constantly arise from others, meaning that our universe could be only a small part of a much larger reality. Despite these ideas, the truth remains unknown. The laws of physics break down at the singularity, making it impossible to investigate directly until we develop a theory of quantum gravity. The question of what was there before the Big Bang remains one of the greatest mysteries in science. Level 95. For centuries, philosophers and scientists have wondered what reality is really made of. At the beginning, it seems simple. Matter and energy form the physical universe. But as we investigate more deeply, reality becomes stranger at the smallest scale. Everything is composed of subatomic particles, but quantum mechanics suggests that these particles do not have defined states until observed. Some theories suggest that reality is not composed of matter, but information, a vast computational process in which particles emerge from mathematical laws. Space and time in themselves might not be fundamental. Some physicists propose that space is an emergent property built on the entanglement between quantum bits. If this is true, reality is not solid, but a changing network of probabilities. Others speculate that we live in a holographic universe in which everything we experience is a projection of a deeper reality in a lower dimension. Then there is the question of consciousness. Is it simply an illusion created by the brain, or could it be fundamental to reality itself? Some theories suggest that the universe could be shaped by observation, meaning that our minds play a more active role in shaping existence than we believe. Despite centuries of discoveries, we still do not know the true nature of reality. Is it particles, waves, information, or something beyond human understanding? The ultimate structure of reality remains one of science's deepest unsolved mysteries. Level 96. Some scientists and philosophers have proposed a mind-blowing idea. What if the universe itself was conscious? This concept, known as panpsychism, suggests that consciousness is not exclusive to human beings, but is a fundamental part of reality, present even at the level of atoms and energy fields. One argument in favor of this comes from the human brain's complexity. If consciousness arises from a network of neurons, could a vast cosmic network, such as galaxies, black holes, or quantum fields, give rise to consciousness on a much larger scale? Some physicists have explored whether the universe processes information in a way that is similar to a massive brain. Studies have even found structural similarities between the cosmic network of galaxies and neural networks in the brain. Quantum mechanics adds another layer of mystery. The famous observer effect suggests that particles behave differently when measured, leading some to wonder if consciousness plays a role in shaping reality itself. If so, does that mean the universe has some form of consciousness? Others argue that this is just a misinterpretation of physics, and that consciousness is simply an emergent property of complex systems, such as the human mind. If the universe is conscious, what would that mean for us? Would it imply some great cosmic purpose, or is consciousness simply a fundamental part of existence, just like space and time? Science has not yet given a clear answer, but the idea that the universe may be conscious in some way remains one of the deepest mysteries of all living beings of level 97 of Earth, who have evolved for billions of years, adapting to extreme environments and adopting countless forms. But could a completely new form of life emerge, something fundamentally different from all we know? One possibility is the emergence of synthetic life. Scientists have already created artificial cells and modified DNA beyond the standard four-letter genetic code. If we design organisms with completely new biochemistries, they could evolve into life forms unlike anything we have seen in nature. Another scenario is extraterrestrial life. If life exists on other planets, it could be based on completely different chemistry, perhaps using silicon instead of carbon, or thriving in environments that are toxic to terrestrial organisms. If alien microbes were to reach Earth, could they adapt and evolve into something new? Even here on Earth, unknown life could already exist. Some scientists speculate about shadow biospheres, microscopic organisms with a unique biochemistry that remain undetectable. If such life existed, it would challenge our definition of what it means to be alive. Beyond biology, artificial intelligence is advancing rapidly. Could a self-aware AI that evolves through machine learning be considered a new form of life? If machines developed autonomy, creativity, and self-preservation instincts, the line between life and technology could become blurred. If a new form of life emerged, how would we recognize it? Would it compete with us? Would it coexist or even surpass us? The future of life on Earth or beyond could be stranger than we can imagine. Level 98. Absolute zero minus 27,315 degrees Celsius or 0 Kelvin is the coldest possible temperature, at which all classical molecular motion is expected to stop. But what really happens at this extreme limit? The laws of physics behave strangely, as matter is pushed to the lowest possible energy state, revealing some of the strangest quantum effects ever observed. At absolute zero, classical physics suggests that all atomic movement should cease completely. However, quantum mechanics tells us that, even at this temperature, particles retain a small amount of movement due to zero-point energy. This means that atoms never stop vibrating and that the uncertainty in their position and momentum remains because of the Heisenberg uncertainty principle. Scientists have been able to cool atoms to billionths of a degree from absolute zero, unlocking exotic phases of matter. One of the most fascinating states observed near absolute zero is the Bose-Einstein condensate. In this state, individual atoms lose their identity and behave as a single quantum wave, essentially becoming a giant superatom. This strange form of matter allows particles to occupy the same quantum state, causing them to act in perfect harmony. Other strange phenomena arise at extremely low temperatures, such as superconductivity, which occurs in certain materials, which means that they lose all their electrical resistance and allow current to flow indefinitely without loss of energy. Similarly, superfluidity appears in liquid helium, where it flows with zero viscosity, climbing walls and moving through microscopic pores without any friction. But is it really possible to reach absolute zero? According to the third law of thermodynamics, no. The closer an object gets to absolute zero, the more difficult it becomes to remove its remaining heat. Cooling to absolute zero would require infinite work, which makes it physically unattainable. Despite this, by getting as close as possible, scientists are discovering new knowledge about quantum mechanics, condensed matter physics, and even possible applications for quantum computing. Absolute zero remains an unattainable limit, but the discoveries made in its search continue to expand the limits of what we understand about the universe. Level 99. What if the universe was a growing organism? We think of the universe as a vast, cold expanse governed by physical laws. But what if it was something more, something alive? Some scientists have proposed that the universe could behave as a self-organized system similar to a living organism. It expands, evolves, and creates complex structures very similar to those of a biological being. Cells divide, replicate, and form larger structures. Galaxies cluster in patterns that resemble the neural networks of the brain. The cosmic web, the large-scale structure of the universe, is very similar to the connections between neurons. Could this be more than just a coincidence? Could the universe itself be a form of intelligence that grows and adapts on a scale beyond human understanding? If so, what is its purpose? Does it think our consciousness? A small fraction of its consciousness, just as individual cells in our body are not aware of the organism to which they belong. If the universe is alive, could it reproduce? Some theories suggest that black holes could be the seeds of new universes, acting as cosmic wombs. Could our universe be the descendant of another? If we are part of a living universe, that would change everything. We would be more than observers of the cosmos. We would be its neurons, part of a system much larger than we can imagine. But the most important question remains. If the universe is alive, is it aware of it? Level 100. Scientists have long been searching for a single theory that explains everything in the universe, a definitive theory of everything. Currently, physics is divided into two main frameworks: general relativity, which describes gravity and large-scale structures, such as galaxies, and quantum mechanics, which explains the behavior of particles at the smallest scales. The problem is that these two theories do not quite agree. One of the main alternatives is string theory, which suggests that everything in the universe is composed of tiny vibrations and strings instead of point particles. It tries to unify all forces, including gravity, into a single mathematical framework. However, string theory remains unproven and has not yet made any testable predictions. Another idea is loop quantum gravity, which attempts to quantize space-time itself, potentially resolving the conflicts between relativity and quantum mechanics. Some physicists believe that the answer could be in an unknown principle, something completely foreign to our current understanding. Others suggest that there may not be a single definitive theory, that nature is fundamentally unpredictable on some level. If a true theory of everything exists, it could revolutionize our understanding of the universe and reveal deeper insights into space-time and reality itself. But for now, the definitive answer remains one of science's greatest mysteries.